So right now we're going to move on to the next session, which is focusing on AI tools that are built here in Tanzania. And I'd love to welcome a representative from PAWA AI. I hope you're with us online.
Definitely.
All right, Tana. So we were to have Dr. Michael Mollel, but I think he's going to be represented by someone else who is going to introduce himself.
I'm here.
Okay.
I'm here. Yep.
Wow, you made it.
I made it finally.
That's awesome. Thank you very much. So please, the floor is now yours. You can proceed.
Okay. So to be honest, I'm the one who presenting someone, not someone who's supposed to present me. So this was supposed to be presented by Winnie Mangeni. So Winnie Mangeni, she's a co-founder and also CEO of PAWA AI. So PAWA AI is a part of Certify product, and Certify actually is a company which we are dealing with developing AI solution, doing a research, supporting innovators, funding a lot of projects, and to mention a few. So this is for PAWA, so let me stick with the PAWA. So my name is Dr. Michael Mollel. I have a PhD in reinforcement learning, actually, and I did my master's in telecommunications, then I shifted to AI. I did my PhD in University of Glasgow, and that's my LinkedIn account. Anyone can scan it and can find a lot of information about myself. So from here, I'm representing PAWA. So PAWA stands for Pan-Africa Wide Alignment Language Model. So that is the idea of PAWA. So what is PAWA actually? So PAWA is designing explicitly for African language model, and anyone can visit the website www.power-ai.com, and you'll see for yourself what's PAWA. Like you see various features, and just for now, we release this model specifically. We optimize for Swahili, but I'll show you the next few slides. You'll see what is our vision for PAWA. So what is the key features for PAWA? So originally, PAWA started for text-only language model, and now we're expanding to PAWA to support any type of speech, from text to speech and speech to speech. So what makes PAWA different is PAWA is built in for African, and its core is African values. I don't know many of you who have noticed this. If anyone can say, okay, ChatGPT is one of the best one. Yeah, I agree with that. ChatGPT is one of the best one. Can you ask ChatGPT to make a joke in Swahili? And if you laugh it, I'll bet it. And why is that? ChatGPT is very good. It writes a very good script in Hollywood. But why not Swahili joke? I think someone can put a comment as answers to it. But as the next session of PAWA, I think Innocent will come to present tomorrow. He will speak much about development of PAWA and how it works. So this is my just nutshell. So our mission, we want to make AI inclusive for everyone in Africa, right? So how to make inclusive? We make inclusive by making small models. So models that can even learn to your devices. You don't have to use a cloud to learn these models. Okay, I like Delta, the way forward. And also, to be fair, I would love to appreciate and thanks very much AfriLab, AI4D by then, University of Dodoma. The idea of PAWA begin in that lab, actually. So we sat and think, okay, what will happen after this AI become more English centric? What will happen for us? So we thought, okay, we can make PAWA. And how to make PAWA? We need data set, we need computation. So we started doing experiment at University of Dodoma. Thanks very much. I have to acknowledge them. I'd like to thank Dr. Nyamawe. I'd like to thank Dr. Mujahidi. I'd like to thank Dr. Matogolo, Glory, and the whole team from AI4D, AfriLab for now. Without them, I think PAWA will not be able to be possible. We did a lot of experiments. We studied there, collecting data. So our mission is to reach everyone in Africa and make AI truly inclusive. So everyone can say, okay, why we need to develop a PAWA or AI system in Africa while we can use ChatGPT? Yeah, that might be a point. But why does someone need to create Hyundai where Toyota exists? Right? So sometimes it's not about just having one thing to monopoly stuff. Because once you monopoly, you can make anything with it. You can even change the narrative. You can even change the thinking. So we want also African to own our own AI. And also, okay, in terms of PAWA, there is a lot of benefit. I will explain them later. So our vision is to break down the language barrier, ensure AI saves all African community in the native language. Not only you can be very good in English or whatever, but even if I want to speak Skuma, yes, you can use PAWA to speak Skuma. Yeah, so evolution of PAWA. So we started, as I mentioned before, we started as text-only foundation models. So initially we developed for language understanding and African language processing capability. So now PAWA, I think, is very good in language understanding in Swahili, but the new PAWAs, which I'll explain later, it has much more capabilities. And our next PAWA, now PAWA consists of speech. So we have various models of PAWA speech from Kinongono, which is a speech text, which is one of the best now in Swahili. And also we have PAWA TTS, which is if you put TTS and then PAWA will output a very good audio of native speaker. And our goal is not only for Swahili. Now we are focusing for all African languages. And then our last one will be adding reasoning. We have started developing a lot of reasoning data sets and image capability. So PAWA vision is to be as good as every large language models, even though it is small. So meet the PAWA family. So PAWA, we have 2 billion model. PAWA, we have 2 billion models, parameter, which is open source. Anyone can use it to try to play with it. It's a DAM. It's not bad. You can use for simple tasks. For example, if you want to do sentence level translation from English to Swahili, Swahili to English, it's very good. You can use it. You can even use to create a data set. It's 2 billion parameter and it's open source. You can go to Certify, Hugging Face, you will find PAWA open PAWA model there. I don't know if you see the QR code. So you can use that QR code to get the PAWA. Yes. What the features of this PAWA Amber? So the current now, if you go to our website, you encounter this called PAWA Amber, which is main model. It trained with 220 billion Swahili tokens, and it's more focused on Swahili understanding. It's currently available on our PAWA chat. So the next training will be PAWA Braze. So PAWA Braze, guys, to be honest, training this LLM is very costly. It's very costly. Just we launched 2 instances yesterday. I just put you the email you see. That email is the actual email from AWS. So because we were trying to training this PAWA Braze, and just for 2 days, how much you spend? 28,000 US dollar. You can believe it. 28,000 US dollar is like buying very good car in Tanzania. But this is how, I mean, it's very expensive. So yes, scarcity or necessity innovation, but at the same time, as a country, we need to join our efforts. We don't have to fight and compete each other. We need to allocate our strengths and try to make this possible. I mean, we can make a clusters from every university, and then we can share our clusters and use expertise to able to train this model. It's very expensive, to be honest. Like, yeah. So that will be a PAWA Braze. So PAWA Braze will have very good NS capability. It will support the tools. The training now is in progress. Training is progress. I don't know. It might take maybe 4 months or 5 months. And the paper of the PAWA will be out also for PAWA Braze. And the last one will be PAWA Spark. So PAWA Spark we're expecting next year probably. But this even Braze, it's almost the training will take maybe 4 months. But as you can see, 2 days or 4 days is normal 28,000 US dollar. It's very expensive, guys. Yep. So so PAWA, why do I need PAWA, right? You need PAWA for your organization needs, right? And because a small model is very cost effective to implement. I know tomorrow I'll speak probably about small language models and techniques to make big language models, large language model to make small in terms of quantization. Yes, they're good. But one thing, if you don't have the data in that big language model, it is nothing. Even if you quantize and make small as much as possible, it is not possible. So you need a framework or a place where you can customize easily. So this is a vision of PAWA. So we want the platform to be able for people to just put your data, or even not your data. You can just say, okay, I'm dealing with agriculture sector, right? So the PAWA will just go there and the developer option. I'm just saying, just query, I just want to make a PAWA for agriculture, and then on background the system will train itself, and then you can have a very good PAWA for your business. This is one of the feature I think it's gonna be available in PAWA soon. So, and also PAWA will support the developer API. So soon we'll launch a public API so people to use it. And tomorrow I think Innocent also for this competition will give you APIs, all APIs from text to speech, speech to text, and text to text. So you guys will love it, and for the sake of the competition, it will last for the competition. You know, we are using GPU. We have our now GPUs, but also we are using AWS GPU. So sometimes we need to balance for the competition. You guys, we wanted to offer for Indaba for the sake of competition, and then the PAWA will be good in developer friendly documentation. So for any developer, if you want to deploy chatbot, you don't need to spend much time. You just need to go there and click like workflow, and then it worked for itself. And so from part of PAWA, we provide implementation guidance, ongoing technical support. So we'll keep you support, and then we customize your solution, what you need, and then you can customize for your need. So PAWA achievement. So someone can ask us, okay, you guys have been developing models. What's the use of it? So believe me, we're serving some government organization. So PAWA is actually government organization. So some government organizations, they use it, and actually they like it because we fine tune especially for their data sets, So our service span from pre-training. So we do pre-training, actual pre-training, because we have one of the biggest, I don't know apart from this big tech, but in Africa, I believe we was one of the biggest data sets ever. So so we don't want to be also selfish. So some of data set, when you release PAWA Blaze, some of our data set, especially for pre-training, will be public. We'll make public because we have the niche of the model. But yes, we'll make some of the data set public once we release one of the Blaze actually. And once we release a Blaze, the Blaze will be closed source, but the Amber one, which is 8 billion parameters, which now saving the PAWA, will also be a public, because we want to give back to the community. So now we are saving some of government organization, and we fine tune and we pre-training based on the data set. We fine tune based on the data set and save them. And most of them, they use small GPUs to learn the PAWA, and they love it. To be honest, they love it. And also because it's much trend. Yes.
Please, can you just sum up in a minute?
Sorry?
So you have 1 minute to sum up.
God. Yeah. Yeah, but anyway, so we serve government, we serve private, we have different partners like Infotaluma and EdTech, so we're saving PAWA for them. And for communities, free chat, anyone can go free chat. And our aim is to democratize AI in Africa. And so why PAWA matters? Remember, your cloud AI or any open source AI does not understand your data. Believe me, that does not understand your data. So you need PAWA. And language is life. So PAWA aim is to preserve language, even though it does not save your application, but definitely PAWA blends to save every application. But if not, still we preserve languages. So we have corpus of many languages, and language is the future, language is life. And we have talked with Gogo and different partners. So stay tuned for public API. I think, Malamsha, you unfair to me. I don't know if it's 15 minutes. I have a lot to talk, but anyway. So this is PAWA, and this is a PAWA experience. And to be honest, I have many things to talk, but time is not my side. Thank you very much. But my advice to people is build. No matter what resources you have it. You don't have to, like Zephaniah mentioned, that sometimes scarcity necessitates innovation. So if you don't have GPU, it's not excuse. Just build with a CPU, right? So PAWA started, we aim for big models, and then we use a small GPU as much as possible, but we made it with a past blaze of PAWA, and now the Spark one we are still developing. So my advice: just build. Just build, and doesn't matter. Is application, is a logarithm? Just build, because everyone depends with everyone. So you can have model, and then that model can serve some people build application. So everyone is an ecosystem. Just do your part. If you are contributing data, that's great. If you contribute benchmark, that's great. The point is do something, and just make excuse of we don't have this, so we don't have to do this. Thank you. I expect many questions, and I need those questions anyway.
So thank you very much. So to participants, please post your questions in the chat box. Dr. Mollel, you can view the chat box, but meanwhile, there is a hand from Jagni. So you can, Jagni, you can unmute and speak. Feel free.
We also have a hand from Aliu.
Yes. So it's Aliu Jagni. It's the same person.
Yep.
Are you guys hearing me? Am I audible?
Yes, you're audible.
Okay, thank you for the presentation. Very, very great though. And thank you for this initiative. I think Tanzania, IndabaX. So I want to ask you, how are you guys gathering data when it comes to the low resource languages that you guys are building? And are you guys expanding to other African languages, or just staying on the Swahili?
That's very, continue.
One other question, are you guys open on collaborating? Because the ecosystem is not that developed. Many startups are doing similar thing in Africa. Why not create an ecosystem that would allow all of us to collaborate and build a very powerful ecosystem that will allow young people and other people that have initiative ideas of building something on top of this ecosystem?
Okay, so let me respond to one of the first question. How do we gather data? So to be honest, sometimes this African language, many of them are not data scarcity. It's not like they're not being gathered in one place, unlike European, where people will just contribute data freely, right? But Africa is different scope. Once you look for data, people, they're starting like demanding for money. But data are there, and especially Swahili, we scrap a lot of data set from internet. We work with Hugging Face, and if you see Find Web 2 paper, my name is there, actual certified names is there, because we're working with Hugging Face to correct data. So we normally like collaboration. It's just we approach a lot of entities like Sunbeds, a lot of entities in Africa, but Africa, is very competitive with environment. The competitive is nothing. Okay, that's the thing I don't realize. Like, I don't know why. yeah, but we like to collaborate with anyone. So for now, as you can see, this is one of the evaluation of one of the benchmark, and the new Blaze will consist of 19 languages actually in Africa. So this is a benchmark, and we're trying to beat this benchmark as much as possible for African language. Yes. So I don't know about another question. So about spanning, yes, we're spanning for. And good thing, now we have customers in South Africa and Nigeria. So that's why some PAWA we developed for Zulu language, and some PAWA we developed for Hausa. So we got, and that's why we wanted to expand our model to consist natively support this, not fine tuning or training for particular language. No, we just want PAWA to speak of many African languages as much as possible. For now, we're tagging this in 19 languages, and we got a lot of copies, and we did abrasion, and it's worked very well for abrasion part of it.
Okay, concerning about the data sets of these languages, some
Yes.
of these data sets, are they open source, or what's the strategy that you guys put in place?
So most of them are open source, but some are not.
Yeah, I can fully understand.
Yeah.
And thank you. I don't want to manipulate the question though. Thank you.
All right, so there is also a hand from Kalebu. You can give your question, but very shortly. Kalebu, karibu.
Yeah, thank you. Yeah, so thank you for the wonderful presentation. So I was just curious to see what is the trend that are you seeing in terms of the use case of the models? You mentioned about government. Mind sharing a bit more in terms of what the use case, like, are they using it for, or maybe not for other clients that you see? What some of the use cases that comes on top?
Yeah, so I don't want to go in detail about governments, but there's a government organization which they provide us the data set, especially yes. So they give us the data set, and the use case they use it is most for writing the document. Actually, is a document writing. So they spend much time just to be creative instead of just making a prompt, and then they can write the document from the PAWA part of it. So that's the most use case we are using. It's not about chatbot, it's just about document understanding, document processing, and business processing.
Thank you.
Yeah, and the problem is I'm expecting those organizations to come forward and to present before us just tell about, okay, we did this for them. No, they're supposed they want to say, okay, we have this AI, and then we use this, blah, blah, blah. That's why I don't want to advertise before them they're doing anything. So that's the reason. But the main business is the in nutshell is a document writing and processing kind of.
So my question is, you as PAWA, what's your area of focus for purposely? For example, you focused on, let's say, in healthcare, and you get the data, and maybe you can pay on healthcare or in financial areas. So where are the area of focus, particularly you focus on the open source data?
So that's a very nice question. Actually, yesterday I had a meeting with Google team, and actually there is the same point. Currently, PAWA don't focus on single use case. Their point is to make AI as a brain, so anyone can just tap it and make application from it. So we don't want to focus on specific use case, rather than we just make AI engine and you come up and make a business from it. So we have one of the demo we call Twitter AI. We have been working for some time. We lack some data sets, so we use OpenAI to generate this synthetic data set, and then we fine tune PAWA for education purpose. The problem of, for example, Twitter AI, we don't make public because it's education, and we want to make sure, okay, it's good, because we don't want people to use to ask to make a simultaneous equation and then it hallucinate. You know, that's why, but we demonstrate, like we can use PAWA to make education, we can use PAWA to make various applications. And this is just for PAWA, but from Certify, we have other business like Dosi Pro and other application, which it's use PAWA. But anyway, for me, it's just because of PAWA, so this is all PAWA. So there's a different. So for Google, actually, they want to give us agricultures and education and try to test it from using PAWA. So still we are on the table and see how it goes, because they want to make a kind of East African application for farmers.
Okay, thank you.
All right, thank you very much. I hope you can hear me.
Yeah, I can hear you.
So meanwhile, for the questions that will be posted in the chat box, you can keep responding to them as we move to the next presenter. So I'd like to take this moment to welcome Kalebu, who will be presenting about his tool Ghala. So we really want to be a little bit strict on time. So Kalebu, you have exactly 15 minutes. So by 12:25, we expect that you'd have summed up. Karibu Kalebu.
Yeah, thank you so much. I hope everyone can hear me. Yeah, I think I might take even less time than that. So let's see. Yeah, so allow me to share my screen. Yeah, so hi everyone. As introduced, my name is Kalebu. So we began, I think for the past 2 years, we began building conversational AI platform. One of the most known is called Sarufi, which basically allow you to build bots. We had like a chat flow that can build bots and deploy on WhatsApp, on SMS, on USSD. Yeah, so we managed to get some clients like Asa Marine, all of these clients. And right here, we were using basically a very, very simple text classifier to just determine intent. But at the same time, we were innovating mostly on utilizing the existing LLMs to power experience. So from our end, the way we think of like innovation in the AI era, there are three phases. There's people who are innovating the foundation models. I think Power AI is one of them, which are now pushing the frontier of the LLMs. And there's people actually building on top of the LLMs. Now it's called the application layer. Those people now like us. So we're utilizing the existing LLMs. We're not trying to train a new model, but we're trying to utilize a new LLMs to just come up with just creative solution on top of it for people. And there's people at the very top. People are now using AI tools to just make money. So if someone using like an AI tool, they're not making it, just using it to do something else. That's like a very top layer. Yeah, so for us with Ghala, we're using it's basically simple. So imagine it's just a traditional commerce, like just an e-commerce platform that where you have product here. Yeah, you have product, you have descriptions, and you want to put it into a chat. Yeah, so there's a problem we had to solve. Like, okay, if you want to put it to chat, we need to solve product discovery. How would people find product on chat? So they'll basically maybe type, I want something. They might make spelling error, and not just that, they might want to change their mind on the mid of the buying process. So we should be able to detect those kind of cues, but also just like monitor the conversational flow that makes sense. Yeah. So if I just put into like a picture on how we're using AI, yeah. So first of all, I think the bigger one is called intent detection. So I think I'll just walk you through it a bit. So the way we built Ghala is not entirely using AI everywhere. It's just using on a segment of part, and one of which is called intent detection, whereby when a customer type, we should know, are they asking a questions, or are they looking for a product, or are they just asking about a price? So we should know better the intent, like an intent of the customers. And then once we know an intent, this is like the big part. It's just like the top layer where we want to understand. But also sometimes the bot can get wrong. And what we're trying now is not live yet. What we're trying to update is when a bot realizes that a conversation with a customer is a struggle, it can automatically notify the owner, okay, there's this customer is trying to buy, but is having struggle here and here and here. This is summary of the conversation. But the one which is live now is basically intent detections. We do conversational search, which is basically traditional. We have traditional searches like vector search, but sometimes for very complex search, we can even use LLMs to do it. Yeah, and just basically for management, something like that. So we managed to build something called chat flow here. So if you come on Ghala, you'll have this section called chat flow. So a chat flow is like now where you can now control all the flow of your bot. Yeah, so it's just like a basic chat bot, but now in every component, as you can see, every component has like connect intent. So if you connect intent, you can actually train it. Okay, if someone type this, they want to do this. So let's say for now, there's like an intent called greetings. And if I check it, there's example. There's no examples basically. It's just use zero shot. So we don't train nothing at all. Just give it an LLMs or this is our intent. So if you say a customer comes to a bot, so this is just a simulator, and say hi. So it takes them here to see this, but how did it come here? Because if I did something else, they say maybe what is Ghala. So this might lead into a different node compared to when I said hi, because hi, you say Ghala is a shop which you offer. So to know what to answer at a particular point, we're now using LLMs. That's why we're using an LLM layer. So if I say I pick something and then I'm here, maybe networks just a minute. Can you hear me?
Yeah. Yes, we can hear you.
You're audible. Continue. Just continue.
Yes. I think it's just a network, not good. But just generally, what we're using it basically. So say there's also like a node, for example, general quest. So as we use it like a number, but the one big that we're using is basically for Omini from OpenAI. So you can actually give it instruction, give it a temperature, but sometimes it can now you can upload your knowledge base. So if you come to settings, you can come and upload your knowledge base here, and it should basically be doing RAG to answer if there's FAQ. But for most of the part, I'll just give you a number. You can just try. Yeah, so it's been a hassle, but we've managed to go a long way because now we're powering almost over 127 shops that are currently using Ghala to sell. And in our early version, we've managed to transact over, I think, 33 million on just commerce chat. Yeah, so I think we're seeing it actually can work. Yeah, and we're looking for ways we can utilize now AI to actually push it to the frontier. One of which including how can we can improve in terms of marketing experience, because every customer that ever talks to Ghala, it's very transparent. You can actually see them here. You can see their chat. How did they ask their question? Yeah, I think my internet is having issues. So let me just know if I can switch to my personal internet. So just a second.
Yeah, seems like you are offline.
Yes, can you hear me?
Sure.
Yes, now I've switched to.
Kalebu, we can hear you.
Okay. So ideally, you can be able to see the entire purchase journey of a particular customer, and that would give you now. We can actually use this to improve the marketing campaign that is very, very personalized. Yeah, but for the most part, as I said, this is like the most of the use case we're using is basically around conversational search. So if you come to a bot and say, for example, ikasema nataka simu na mango, so it should be able to know this is trying to search a product and should bring me those products. So it went and give me 2 products. So and if I look at there is this smartphone, which is actually a phone. So I think just a minute. So if I click here, it brought me a mango and a smartphone. But if you look at smartphone, there's nowhere you type SIM, or if and this is type mangoes. So it's not doing like a traditional search to bring a result. It's just using LLM, like smart conversational search, and in that way, customer can now proceed. If they want to purchase something, they can just go, let's say, just take like a smartphone, and can just go all the way to choose how they want to pay. If it's mobile, it's gonna put their PIN, and then they get a push prompt. So this is how we're using it for this natural language search, answering common questions, but sometimes knowing when to actually trigger the customer. Okay, yeah, and you can just organize it. You can create multiple intents here, and then just kuna mtu akisema maybe kwa mfano if I've I think this was a test and test intent, so I can create like a test like this was a test like intent. I just made it a couple of examples, but even if you don't give examples, just walk and then it goes to this particular response. So if I say I can just say cancel it, and so maybe iPhone. It led me be called iPhone. So it didn't do any product search because there's an intent here. So this is just a very like high level, the way we're using it. In that way, we're minimizing reliance on utilizing AI everywhere, which basically will skyrocket our expenses of token. So I think if you want to try out, you can just so if you want to try out, so if you come to the main page, you'll find some of the merchants that are active using Ghala to sell are here. So yeah, with people doing from commerce, fish, people selling digital products, restaurants. So you can just, if you want to try on your end, you can just you can just go and you can scan this QR code. Maybe like say I want nataka simu na maybe diapers. So you can just scan this QR code. It will take you to the WhatsApp number. You can try purchase, and you can actually see here. So yeah, scan the code. I think I'm done for the most part. I hope you have scanned the QR.
So from my end, I cannot see the QR code.
Oh,
I'm seeing a chart of Luvanda here.
You cannot see a QR. Can you see now?
Still no from my end. Is it particularly just me, or is it from everybody?
Me too.
Yeah, as well.
Me too, I can't see it.
Yeah, we only see a Luvanda chart here.
Let me then let me stop sharing and share the window again. Can you see?
Yes.
Yes. Yes, now it's visible. Thank you.
Okay. So this is just a number of this shop that I'm currently using. You can just go there, try to chat, try to purchase. You can ask it questions and you just see how it works. And then for developers, I think for right now, we don't have like very smart LLM API, but you can just, for everything that happened on Ghala, you can actually link it to your external system. So you can actually, everything that happened on Ghala, you can just get a payload to your system. So some of the people are using this basically to, so the client who have a mobile app, I think Cholink, they have a mobile app, but they're using Gala's pay on WhatsApp. So you can just explore, but I'm also open to question. I think that's a very overview of what we do. And every frontier that we're trying to do is basically trying to build more on the application layer on how we can solve commerce on chat using AI. Thank you.
All right, thank you very much, Kalebu, for the amazing presentation. So we're only going to have one question from Lucas Constantine, who has raised his hand. And then you can respond to any more questions in the chat box. Lucas, karibu. Lucas, if you're trying to speak, you're on mute.
I think I can respond to Ponciano Francis on chat. He's asking, are we vibe coding? No, we don't vibe code because it's very, very hard to maintain a vibe coded app. Vibe coding is basically if you're trying to do a prototype to show someone, but if you're trying to do something long team, I don't advise you should vibe code it. But our team basically is very competent, but also we utilize a lot of tools like Copilot, Casa to actually speed up the process, but we don't vibe code this. Yeah, thank you.
All right, thank you very much, Kalebu, especially for keeping time. So we are going to move to the next tool. So for now, we're not going to have Twiga. We're going to have Saratani AI. Saratani AI, Dr. Sangudi, please confirm if you're already online.
Yeah, can you hear me?
Yes, we can hear you.
Okay, thank you. Yeah, hello everyone. And I hope you are doing great. So just want to show a little bit about Saratani AI. Allow me, I'm sharing my screen. Yeah, can you all see my screen?
Yes, we can see it.
Okay, yeah, thank you so much, Anna Grace, and I'm humbled to be part of this event. And I'll be sharing briefly about Saratani AI journey, what we are doing, what our next step, and what are we looking for. So my name is Samudi Samud. I'm a medical doctor. I graduated from MUHAS. As you can see, this is just a short story about my life. Actually, I'm a medical doctor who started. Oh, okay. Sorry, am I audible enough?
Yes, you're audible. You're audible.
Oh, okay, okay. So this is my short story. I'm a medical doctor who started programming in 2018. And then now I'm more interested in combined medicine and technology, especially AI technologies. So I'm a co-founder of Saratani AI, a startup that is revolutionizing cervical cancer screening by making it fast, accurate, and affordable. So kwa Kiswahili, cervical cancer ni saratani ya mlango wa kizazi, of which is one of the most deadly cancer in women and one of the cause of mortality in women. So these are the numbers about cervical cancer. So it's a huge problem. Like most of the women, they get diagnosed at a very late stage. For instance, this is something that I witnessed at first hand when I was doing my clinical rotation at Muhimbili National Hospital. You would see a lot of women, they arrive at the hospital at a very late stage in such a way that they end up just having palliative care and they cannot be treated entirely, of which this is contrary. If cervical cancer can be detected at a very early stage, it can actually be cured at a much cheaper price and be affordable. So when you look behind all these scenarios, there's a lot of daunting reality. One being like most of the cervical cancer screening, actually they are hospital-based, they are slow and expensive. For instance, doing one of the tests, which is pap smear, it actually costs like 8,000 Tanzanian shillings. So you can imagine for our mothers and sisters who are coming from like village life, it's very hard to have this. But also we have very shortage of experts in terms of the pathologists or the expert doctors that are supposed to do this kind of test. And there is a lot of there's a lot of errors and a lot of mistakes that are being made in the process of cervical cancer diagnosis. But also it takes 1 up to 3 weeks to get the results, which make it a very huge problem. So what usually is being done, a woman will visit to a hospital whereby they can choose either to do pap smear, whereby they will take a sample from the cervix of the woman and then they process it in the lab. After processing the lab, they send it to a pathologist, probably in the tertiary level hospital, which it takes, as I said, 1 to 3 weeks to get the results. So this is something that we are changing at Saratani Eye by using actually 2 approach. And the way how we are doing this, first of all, the sample for the case of the pap smear, the sample will be taken in a very normal way, and then it will be processed in the lab. And then from there, instead of sending to pathologists, what we do, we actually capture the image from the slide and upload it to the system, and you get the results instantly. So this is how it's been done. So a sample will be collected and then processed in the lab. And then the image will be captured by using a digital microscope, and then it will be uploaded in our system. So this is it was elementally sketched for how we developed our model. Now we are using much more powerful models apart from the LesNets. So basically what we are doing is image classification. I've seen the previous speakers, Kalebu and Dr. Mollel, they've been speaking about the natural NLP, most of the LLMs in most of the applications. So ours basically of image recognition and image classification to identify where exactly the lesion is. And currently you can have the results in under 2 minutes with the accuracy of 95%. And we are reducing the cost from 8,000 Tanzania shillings to approximately 5,000 to 10,000. So we are much more focused on the volume rather than the expensive test on it. So the other parameter is on the visual inspection by acetic acid, whereby in most of the circumstances, this is how it's been done in our hospitals. Like a woman will be put in examination position, and then nurses will look at it and say that if this is normal or abnormal. You can see this is much more, it depends much on the human factor. So if the nurse makes a mistake and say this is normal, while it's not normal, you know the implication about that. But also there's a large number of patients. So these also are human beings where sometimes they get tired from the work. They have a lot of things to do. So what we are doing, we are also digitizing the process by using an endoscopic camera, which is actually capable. You can connect it via a mobile app or laptop. And then we have this special tool, which we call it Spectrum, in such a way it can give you accessibility through the back canal, and you can visualize where the cervix is. So what we are trying to do, you can actually capture an image from this, or you can record a video. And after recording the video, we are going through various stages. So the first stage being like, okay, as you can see, these are the A1 images. These are just images that have been visualized from the endoscopic camera. And then we can process it and segment it so that we have this high quality images, but also to remove kind of reflections or light variations so that to have something which is well intact, can be visualized very easily by these nurses or doctors or midwives. So, and again, it's not only that, our system is actually capable of going and highlighting where exactly the lesion is, and provides possible recommendation on what is going on about the woman, as you can see. So I think we'll have a live demonstration on that. Actually, I don't have access to service, but at least I'll be able to show you how it works. So allow me to show some of the best demo on how we are doing this. So this is a simple system of ours, and we are looking forward that after the image has been captured by using a digital microscope, what is supposed to be done, you can actually go and upload an image. For instance, this is pap smear image that you can upload. Sorry about that. Yeah, so for instance, this is a pap smear image from a woman known as Amina Juma, for instance, whoever, that has been captured, has been processed, and then you can upload it in the system. Once you upload it in the system, you can actually submit, and on the instance, it will be able to give you the classification. So there are various levels for classification of cervical cancer, precancers, like lesions, and this is one of which, and it can actually provide. It can actually provide with the clinical reports. And we went further and tried to do, we call it GradCam, or gradient activation map, to highlight where exactly the lesion is. And currently we are operating at an accuracy of 95. So this is just a simple sketch of how Saratani eye works. And you can see it didn't take 1 or 3 weeks to have this kind of results. Just under 1 image, then you have the results. So why make someone wait for more than a week just for result that can be provided within a very short period of time? And then sorry, let's go back to where we are. Yeah, so, and then after this, so actually we know this is AI and it is automatic, but still we want to give the autonomy or power still to medical doctors, nurses, or midwives that will be using this system. So before even sending reports to a patient, they have to look at it and approve in such a way that they can override the decision, or they can approve it to make sure that the ethical and moral concern about the systems are all like addressed about it. Because the idea is not to replace doctors, it's not to replace nurses, but rather to empower them to be able to do a large number of analysis within a very short period of time. And okay, so in our value proposition, actually working at a speed of 40 times the conventional way for cervical cancer screening. We're operating at an accuracy of 95%, and actually making the costs more affordable by more than 75%. So we've actually published a paper about this methodology. And if you look at the competitive analysis with the other solutions that are already on the market, we actually train our model using locally available data sets, something Dr. Matogolo was speaking about, that we are in Africa. So whatever that we are doing, it has to be something that is contextualized based on our settings. So we actually partnered with 2 hospitals in the country, that is the Muhimbili National Hospital and Ocean Road Cancer Institute, whereby we were able to collect over 3,000 images actually from our setting, and we were able to obtain ethical clearance from Muhimbili University of Western Allied Sciences. So far, we've raised like $8,000 for research and development purposes. So our targeted customers actually to work with public and private hospitals that's they're offering the cervical cancer screening, so they can choose. For tertiary level hospitals, they prefer using I'm having echo issue. So the apologies. Okay, so for tertiary level hospitals, so what they do, they use a much advanced test, which is pap smear, of which I've demonstrated a demo for it. And then for the primary healthcare facility, the recommended method is visual inspection by acetic acid, whereby now we have the endoscopic solution for that. So it's like an end-to-end solution. So they can do it on the primary level, and then by using endoscopic camera, and then after that they can go to tertiary level hospitals, and then they do the analysis by using pap smear test. So as a call for students who are doing computer science or anything that they are interested in building something people that they can use, please, you can reach up to me. There is a lot of things going on at Saratani, so you can volunteer or like an intern. So I welcome you to work with us on the volunteer or interns so that we can make much more impact in the community. And just to wind up, since this is the event regarding deep learning in IndabaX, so for this year, I was selected to go to the African event that will be conducted in Rwanda from 16th to 22nd. And I think it was one of the adverts that Tanzania community was promoting it, I think around February to March. So I did the application on that, and I was able to be accepted with a couple of fellow Tanzanians that will be joining with me in Rwanda, I think, next month. So it's just a call for you all. When you see all these events, all this application, just apply. You never know what will happen to you. And always, I usually like to say that you always belong where you think you belong. So if you think you can work something in software or AI, you just try whatever that you can, whatever resource that you have, and I think everything will be okay at the end of the day. So I think I would welcome questions. Yeah. Okay, Juma.
Okay, good. I'm really thank you for your presentation. And my question is, I was working with this project on the segmentation of those cervical cancers images, and this 2 months ago. And one of the challenges that I was faced on is the needs of those data, and from two challenges that was arises. First, on the availability of data set, and second is availability of legal issues. On your side, how do you overcome these challenges?
Okay, yeah, thank you for the question. And I think it's one of the excellent questions and relevant questions. Actually, I started working with Saratani AI since 2020, and March we were relying on public available data sets. So we had a lot of challenge for the first 2 years until when we got support for funding, and we were able to buy our own microscope that we installed at Muhimbili National Hospital and Ocean Road Cancer Institute, actually to be able to collect these data sets. So we have the data sets in our country, but probably they are not in a way that they can be utilized. So you have to be aggressive enough to be able to do that. So if you're interested on the kind of data sets that we are working on, I think you can reach out to me and see how we can help you. And all of this is possible, but you have to follow like procedures. I know most of the institutions, they have their ethical ethical review guidelines. So, and because something that has to do with AI and human health, you have to follow the procedures. And I think there's a lot of people that are doing research around these areas. We just need to identify those individuals. But I'll be happy to welcome you. And like if you have something particular to do with our data set, if something that you are looking for, I think we can help you with that. Yeah. Did I answer your question?
Yeah, exactly. And how do you overcome the issue of privacy on those images that you have?
Okay, so first of all, we don't train our data sets on the cloud infrastructures because these are the patients that are the data that are coming from the patient direct. They're not online public available data sets. But also what we do, we actually anonymize it. So we are not collecting anything to do with patients' particulars like name or anything that they can any information that they can identify the person or individual who like contributed to this data set. So it's something that we anonymize, but also we are not allowing our data set to train on cloud infrastructures. So what we do by we have GPU machine at MUHAS. We have like we call lab for imaging technology. So that's some machine that we are using there to train. Actually, at the end of the day, on scaling, we'll be able to use these huge cloud infrastructures. But the issue is most of this health data, especially data involving individuals, are kind of sensitive, and probably we don't want to be on the other side of legal issues. That's why most of the thing we are doing is contextualized locally. Yeah. Okay, so I think two raised hands. So can start with you don't have.
Okay. Okay, thank you very much. And my question is, I've already seen the demo that you are uploading that image and providing some detail, but how your system or your model can understand that people like normal users that do not have knowledge in, let's say, in technical or that in health, can understand that that interpretation of the model in order for him to know very well his or her problem. And because I've seen a lot of plot there, a lot of graphs, so how does your model can understand and provide the easy explanation to those people that do not have a knowledge in technical or in health sectors? Thank you.
Okay, thank you. I think maybe I missed your name. Thank you for that great question. I think it's something that I didn't put clearly on my presentation, that this solution is not for patients. Patients are only beneficiaries. So the users, the targeted users for this solution are medical doctors, nurses, and midwives who they are able to do the cervical cancer screening. So not everyone has access to use this system. They'll be approved based on the what do we call professional association of their, for instance, medical doctors. They have Medical Council of Tanzania. They have to be registered there to be able to use our system. And for patients, we'll be actually providing like basic information for the patients, not something that will be very confusing at that level. So this is on high level profession because it's expected to be used by medical doctors. That's the case.
Okay, thank you very much.
Okay, so I see, Dr. Mollel, nice to meet you again. I think you've been waiting some.
Yes, continue, please.
Yeah, go ahead.
Thank you very much. Thank you very much. And nice seeing the good progress of Saratani AI. And I think I was there in the inception of Saratani AI. You guys are doing very amazing work. I have my reservation actually, and I just need, it's not a question like, but part of kind of collaboration. Like I've been hear the rumors, and to be honest with you, some people trying to reach Saratani AI to borrow the devices, for example, to do the same experiment. I mean, we are in the ecosystem, and I think your device is Ocean Load, and it seems Saratani AI is refusing at least to give to the other student who want to use it. Is that true? I don't know. It's probably is not the right time to ask you, but I can't help myself.
Okay, yeah. Thank you so much for the question. And I think what I would say, I don't know to what extent, but what I know, I was glitched by someone, and I think we granted access to that. Apart from that, I've not had anyone just want to use the tool from Saratani AI. Probably if you can just let them contact us directly, I think that will be possible. So there's this thing like because we provide this equipment to hospitals, like some kind of donation to hospitals. So maybe something that will be happening. Maybe they are being denied access from the hospital, like from the hospital direct. But I think if they can reach to us direct, I think it will be easier for them to work with them. Yeah. So that's what I understand. I think this is the ecosystem, and I think we have a very big data set. So people that want to explore about it are warmly welcome.
Thank you very much, Zangut. And actually, I asked you your number, so please, I'll reach out to you. Thank you very much.
Yeah, my DMs are always open. Thank you so much, Dr. Mark.
Thank you.
And we have Godfrey Semaiko.
So
yes, thank you. Can you hear me?
Yeah, I can hear you.
All right. Thank you, Dr. Sangudi.
Yes.
Naweza kuuliza kwa Kiswahili, kila mtu anajua Kiswahili humu ndani, au niende kwa Kiingereza?
Ni sawa.
Au nichanganye?
Ni sawa.
Nimependa. Niko Taiwan, nafanya PhD ya digital media design, na nimealikwa tu, sijui lolote kuhusu beginning of this platform, but nimekuwa interested kwa sababu inahusu AI in Tanzania. I've done some researches in AI. Kwa nini umeamua kutumia ResNet as a CNN model? Kwa sababu najua kuna model zingine zinafanya vizuri zaidi kwenye 3D images, kwa sababu unatumia endoscopic cameras kuchukua images. Sasa kwa sababu endoscopic na mwili wa binadamu ni 3D, je, umewahi kujaribu labda model zingine za CNN katika kutengeneza model yako ya Saratani AI? Pia kabla sijaenda mbali, ni kushukuru sana kwa sababu most of the AI models zinazotengenezwa kwetu Afrika na nchini zimekuwa LLM, zote zinakuwa kama vile chatbot, zote zina deal na languages, hakuna zinazo deal na images. Kwa hiyo nilivyoisikia ya kwako nimefurahi, na mimi nimefanya some researches za images kwa artifacts za Africa kwa kutumia hiyo CNN models. Je, kwa nini, swali langu kubwa ni kwa nini, kwanza pokea shukrani na hongera, na pia kwa nini ResNet only?
Okay, sawa. Asante sana Mr. Semaiko.
Dr. Sangudi?
Yes.
Because we are running out of time, please just respond quickly, and then any more questions can be posted in the chat box.
Okay. So labda nijibu swali la Mr. Semaiko. So ile ambayo nimeonyesha is just a basic sketch of what we are doing. Actually, we use the state of the art models for image classification, LesNet being of them, because also LesNet, it has generation, LesNet 152, LesNet 52, we have MobileNet, we have InceptionNet, we have GoogleNet, we have all of this. So we tried with all of them, but also fine-tuning them. Actually, even though in most of the literatures they say LesNet was performing very well, actually in our case, MobileNet was the one, version V7 was the one that was performing very well. So this was just to show the stage, not just we are using, it's not like only LesNet. Actually, the one that performed well in our setting was MobileNet V7. And that was, I think I showed two solutions, one being PapSmear, and the other, the visualization that is a 3D. Is something that we are working on. So it's not only about LesNet. Yeah.
Can I add something on that? If allowed? Yeah. So Godfrey, normally you before training any AI stuff, you need to have the benchmark. So whatever the AI can beat the benchmark, that's the thing you can go with. And if, for example, you said you can tolerate 1%, right? Error, for example, you set to a benchmark, you need to achieve 99% accuracy. And for some reason, net is small, for some reason, or maybe it's fast, and it achieve better. So why you need to roaming around, why you can have the solution on hand? So we know, okay, most papers, they try to show like different models, but if you can have very simple and very powerful robust solution, I think that's a way to go. And I think LesNet is one of the simplest one compared to complex like ExceptionNet and other complex. You might need it if the original models fail or small models fail.
Thank you so much.
All right, so thank you very much, Dr. Sangudi, for the amazing presentation and the questions. So if there is any more questions, please use the chat box. So because so I'd like to bring something into your attention. So at Tanzania AI community, we usually do various AI spotlights for various individuals. And today, right here at Zanzalu, we have one person that we have spotlighted. And that is none else but Dr. Sangudi, who was just presenting the Saratani AI. So I'm going to welcome him. I'm going to welcome him so that he can so that he can say hi again. But most importantly, he's one of the people that will be attending the deep learning in Indaba in Rwanda. So he's just going to share like a 1-minute testimonial. So karibu sana Dr. Sangudi.
Yeah, thank you so much, and I guess for the amazing work, and nice again to meet you all. So as I said, my name is Sangud, and I'm so happy that I'm representing Tanzania to the deep learning in Indaba in Rwanda from 16th to 2022. I think we have others, I think Asha and Sila Case, I think they're joining us on that. So I started applying for deep learning in Indaba in 2023. So they rejected me. 2024, I was on waiting list, and this year I made it there. So what I can just say, just do your thing in whatever place that you are. People, they usually see the impact that you are doing, and you can get a lot of support along the way. So for the next coming deep learning Indaba, I'll be happy to mentor people that they want to apply for that, and also I'll be happy to help in any other way for people that are building in AI, software engineers, as I said. So if like you want to join this mission of building, because I like building, please reach out to me. We have a lot of things that are going on, and I think we can be part of this, and we can build something that's really been applicable in the healthcare setting in Tanzania. Thank you so much. Yeah.
So while you're still here, Dr. Sangudi, so we do know that we had an amazing keynote address from Dr. Matogoro, and because I still hope you're still with us.
Sorry, Anna. One question, the doctor is asking us to, we can reach out to him, but there is no any contact details. Can we get the contact details, please?
He's going to put the contact details on the chat box soon. I hope that's all right. So we had the good keynote address from Dr. Matogoro, and he has been a person who has been contributing greatly to the AI community. So we just have a little surprise for him. It's an appreciation award, and because he's not with us at Zanzalu, Dr. Sangudi is going to be getting it on his behalf, and then he's going to help us present it to you in Dodoma in the near future. So for now, I'll just show you the trophy. I'm not sure if you can see it.
Yeah, wow, I see it. Thank you so much.
Right. So we are going to handle this to Dr. Sangudi and then figure out how it's going to reach to you, because you are a senior professional who has done great things in this space. And Dr. Sangudi is a young professional who is inspiring other youth to do good. So I believe he's also the right person to take it on your behalf. So we are going to take pictures handling the trophy to him on your behalf, and then you're going to get it in the near future. So
Thank you so much. Asante sana.
All right. So we are going to take 4 minutes break and resume right after at 1 p.m. with the presentation from Elina. So during this break, I'd just like you guys in your hubs or wherever you are to just kind of like stretch or something. Yeah, so we're going to have a presentation on education robot from Elina Ntahomvukye, who is from Zumbe University. So I think we shall resume at, yes, so 5 minutes past 1 exactly. So you can just stretch, move around. If you can have icebreakers in your respective hubs, select someone who you know is very good at icebreakers so that you guys can be active a bit, and then we shall resume at exactly 5 past 1. So it's 5. Ntahomvukye. Elina.
Okay, yes, I'm here. Can you hear me?
All
Hello.
right.
Can you?
So nice to see you. And I see.
Okay.
Yes, we can hear you loud and clear.
Okay.
Yes, we can hear you.
So,
when you.
Thank you.
We see that to hear what you carry.
Okay. As Miss Anna Grace said earlier, that my name is Elina Ntahomvukye from Zumbe University Hub, and we are here to present the usage of social robots in enhancing teaching and learning mathematics in Tanzanian primary schools. So the idea of using social robots comes from the fact that in recent years, mathematics performance among the pupils has been low, and one of the contributing factor to this high failure rate in mathematics is due to poor teaching and learning environments. So, which often cause the student to lose interest or motivation in learning the subject. So, as we know that the mathematics subject is vital subject in STEM field, which is the key to national development. STEM field stands for science, technology, engineering, and mathematics. So, in comparison to other developing countries, they have adopted many various innovative solutions to improve their teaching and learning environment. And one of the promising approach is the usage of social robots in education, children education. So we believe that if we introduce the ICT, particularly social robots, to children early, especially in the language children that can understand, for our context is Kiswahili, we can both improve learning and also spark long-term interest in STEM subjects. So to help us to build a savvy, tech-savvy future generation. So we start with a mathematics lesson, particularly in teaching geometry, to engage students interactively. And it has been this solution of using social robots to teach geometry topic in primary schools have been piloted in some schools in Dodoma and Morogoro, and the results have shown promising outcomes. So in future also, we don't rely only on the usage of social robots, but also we plan to develop an intelligent tutoring system that's leveraging the large language model to further support teachers and personalized learning for pupils. So with that said, I would like now to show you a short demonstration video that can give you a proper understanding of what I was talking about. Yeah. So let's take a look.
Majina naitwa Elina Ntahomvukye, ni mwanafunzi wa Masters Chuo Kikuu Mzumbe. Tunashirikiana na mradi wa freelance katika.
Oh, sorry. Can you restart? I was going to share, but if you're going to share it, please do.
Okay.
Majina naitwa Elina Ntahomvukye, ni mwanafunzi wa Masters Chuo Kikuu Mzumbe. Tunashirikiana na mradi wa freelance katika kusaidia kuboresha elimu ya shule ya msingi katika
Yeah, Elina, we're
masomo
not
ya
seeing on the screen. Can you? Yeah, thanks.
engineering. Leo hapa tupo na teknolojia ya roboti. Majina naitwa Elina Ntahomvukye.
Sorry.
Ntahomvukye ni mwanafunzi wa masters chuo kikuu Mzumbe. Tunashirikiana na mradi wa Freelance katika kusaidia kuboresha elimu ya shule ya msingi katika masomo ya hesabu, sayansi, teknolojia na engineering. Leo hapa tupo na teknolojia ya roboti. Kwa sasa roboti wetu anaweza kufundisha topic au mada ya geometry, ambapo ataenda kufundisha maumbo matatu: mstatili, mraba na pembe tatu. Na katika hayo maumbo yote matatu ataenda kufundisha eneo na mzingo.
Karibu wanafunzi katika darasa la geometry. Jina langu ni Mwalimu Asha. Tutajifunza maumbo matatu ambayo ni mstatili, mraba na pembe tatu. Upe kitufe cha umbo unalotaka kuanza kujifunza kati ya mstatili, mraba au pembe tatu.
Kwa sasa mimi ndo nitakuwa mfano wa mwanafunzi. Kwa hiyo mwalimu wangu Madam Asha wakati ananielezea, mimi nitakuwa nafuata maelekezo yake.
Jambo wanafunzi wapendwa, siku yenu imekuwaje? Leo tutaangazia somo letu la hesabu, kujifunza juu ya umbo moja maarufu tunaloitwa mraba. Sasa mraba ni umbo la kijiometri lenye pande nne zilizo sawa. Ina maana kwamba ukijua urefu wa upande mmoja, basi utajua urefu wa pande zote. Tunaweza kufafanua zaidi kwa kutumia mfano. Fikiria mraba ambao kila upande wake ni sentimita 15. Je, utajuaje mzingo wa huu mraba? Ni rahisi tu. Jambo la kufanya ni kuchukua urefu wa upande mmoja ambao ni sentimita 15, kisha uzidisha kwa 4. Kwa nini tunazidisha kwa 4? Kwa sababu mraba una pande 4 na tunataka kujua jumla ya urefu wa pande zote. Hivyo, tunapozidisha 15 kwa 4, 15 zidisha 4, tunapata 60. Hivyo, mzingo wa mraba wetu ni sentimita 60. Sasa, hebu tuone jinsi ya kupata eneo la mraba. Eneo la mraba linapatikana kwa kuzidisha upande wa mraba mara upande mwingine wa mraba. Hivyo, kama upande mmoja wa mraba wetu ni sentimita 15, tutazidisha 15 kwa 15, 15 zidisha 15 na hivyo kupata 225. Hii ina maana kwamba eneo la mraba wetu ni sentimita za eneo 225. Natumai sasa mnaelewa vyema kuhusu mraba, mzingo wake na eneo lake. Endeleeni kufanya mazoezi na kufurahia hesabu.
Hapa kama wanafunzi bado hatujaelewa, tunaweza tukabonyeza mifano zaidi ili kupata mfano, au tunaweza kubonyeza zoezi ili kuendelea kupata zoezi.
Tafuta eneo na mzingo wa umbo la mraba wenye urefu wa upande wa sentimita 12. Wanafunzi, jibu lako la eneo ni sahihi. Hongera wanafunzi, jibu lako la mzingo ni sahihi.
Tunaweza kubonyeza sasa ili kupata zoezi lingine. Kwa hapa mfano mwingine tunaweza tukakosea, tukachanganya kanuni ya eneo kutafuta mzingo na mzingo kutafuta eneo.
Na mzingo wa mraba wenye urefu wa upande wa sentimita 16. Si sahihi umebadilisha kanuni. Umetumia kanuni ya mzigo kupata eneo. Tafadhali hakiki tena mahesabu yako vizuri. Kanuni sahihi ya eneo ni upande zidisha upande 16 zidisha 16. Jibu sahihi kwa eneo ni 256 sentimeta za eneo. Wanafunzi, mzigo si sahihi umebadilisha kanuni. Umetumia kanuni ya eneo kupata mzigo. Tafadhali hakiki tena mahesabu yako vizuri. Kanuni sahihi ya mzigo ni jumla ya pande zote 4 au pande zidisha 4, 16 zidisha 4. Jibu sahihi kwa mzigo ni sentimeta 64.
Asante. Kwa jina naitwa. So, as you have just seen, by combining technology with education in a way that it fits our local context, we believe we can improve learning outcomes of our pupils, but also we can inspire the next generation to pursue STEM fields with confidence. And that's marked the end of my presentation. Thank you for your attention.
Great, thank you, Elina. That was great. And we have a question here from Suahub. Elina?
Yeah, thank you for the nice presentation. I'm having a question. I'm curious on the method, like how the robot is teaching from the normal books we are having and the method they are used in schools.
Okay, first the contents were extracted from the national curriculum, mathematics curriculum, and since the robot doesn't have a screen or a display for visualizing the content, that's why we use a separate computer for visualizing the content that the robot teaches. So for now, we concentrate on building or combining, we see how the curriculum of our country, then we develop a web-based application based on the curriculum, then we integrate it with the robot so it can provide the lesson. I think I answered your question.
Yeah, so how would that?
Sorry, I can't hear you well.
Hello? I'm asking how does it get to the end users ambao ni wanafunzi? The target is to help students get the concepts. Yeah, like for here ambao representing geometrics. Now, how do the students use it and access it from our schools? And is it going to primary schools, government to private, or both?
Yeah, for now we have done the piloting. First, we must understand that we are at early stages. So we have done piloting to various, as I've said earlier, to some of public schools in Morogoro and Dodoma. So we don't have the clear plans on how these robots can be used in normal classroom. Rather, we know as Nzumbo University, we based on research. So this is kind of research-based solution that how the social robots can be used to improve teaching and learning environment, especially in mathematics. So that's why I've said earlier, not only the social robots, but we have the plans for extending the solution for developing intelligence tutoring system that can further assist teachers and pupils, not only the social robots to be employed or to be deployed to classroom settings. So right now we had only piloting.
Thank you, Elina. Do you see that there's 2 questions in the chat?
Okay.
3, actually. You see them?
Okay, I think the first question is how the robots can improve their learning activities, which is not available in human who is teaching mathematics. Okay. First, we know the nature of our classroom environment, that we see teacher-student ratio is very high. So these robots can be used to provide a personalized learning, which is very difficult to be provided in normal classrooms. And also, the next question is, how much power does the robots need? I don't understand the power. What the extent of, what do you mean the power? I mean the power of the battery, or the power of what technology can be the input for the robot to work? I don't see that very clear, but if you consider that, please. So I can take this. Have you considered how pupils from rural areas with no electricity are going to benefit from this? Yes, we thought of developing, that's why I said earlier, not only the robots to be there, not only necessary for the robots to be there in the classroom, but we opt to have, to develop a system that can work without the need of electricity, means using of intelligent system that cannot need support, much support from the power electricity. I think I see a lot of questions coming from the chat bot. So,
Elina, so I think maybe you can continue answering the questions in the chat while we continue to our next speaker. Is that okay?
Yeah.
I think there's like 2 or 3. They might keep on coming. Thanks. I'll introduce her.
Okay. Now we are welcoming Fredy Mgimba and presenting on Twiga, empowering Tanzania education with AI.
Yeah, Fredy, are you ready to present?
Okay. Okay, we skip Fredy Mgimba for now. He'll come later once he's back. Now welcome Dr. Kulwa Malyango, AkiliCheck, empowering Tanzanians with affordable and reliable healthcare. Dr. Kulwa, karibu.
Yes, Kulwa, are you there?
Yeah, I'm here. Thank you. Thank you, everybody. My name is Kulwa Malyango, and I hope to be a doctor in the future. I'm not yet there. So I'll be presenting on AI for mental health, and let me share my screen. Is my screen visible?
Yes, we're seeing it.
Yeah, thank you. So here at AI for Mental Health, we developed two solutions for diagnosing mental health. One from the point of view of patients themselves to self-diagnose, but it's a little bit limited for ethical issues. But I'll start with the one that we created for psychiatrists or professionals who can be used to use the tool. So when diagnosing mental health issues, it's mostly approached through interview and certain data collection about the individual who has mental health issues troubling them. So it may be interviewing the patient themselves or the people around him, or investigating to collect data about that particular individuals. Others go as far as using computer visions, and others go as far as using EEG, those tools that are planted to the brain, maybe to study the electricity or whatever goes on in the brain. I won't even pretend to be that much technical. But the one that is mainly used in Tanzania is basically through investigating and interviewing maybe the patient or the people associated with the particular patient. So that's the one that we try to automate using natural language by using small transformer models called BET. So the idea is that a normal psychiatrist, through investigation and through interview, can land to a diagnosis earlier. They call it, I think it's provisional diagnosis, and understand or get a picture of what may be troubling the individual. But there are other mental health issues that can be triggered by other diseases in the body. So this tool can help other medical practitioners, even in the normal outpatient doctors, OPDs, to check the mental health status of their patients if they are behaving differently. For example, malaria can lead to some sort of psychosis, and let's say also there is something called I think it's postpartum depression. The mothers do get depression after delivering babies sometimes. So having a tool that can help any other doctor who is not a psychiatrist to identify or get a glimpse of what may be troubling their patients mentally can help. So that's the tool we created. So let's say we're using this patient right here. And the interface, by the way, it's just for, let me log out and log in again, sorry. I think it was a session issue. So the interface is basically mostly for proof of concept, but because healthcare systems already have systems to use, the idea is that this can be used as an API, not necessarily as this interface used right now, because it will just add on the plethora of tools they already have, and they don't want to have a lot of tools to interact with something. So they can just use the API to interact with our AI solution. So let's say a patient comes, it's a new visit, and they will be registered here. So I'll walk you through. So the investigation or the interview will be aimed to get these fields and be as verbose as possible, or to express the interview or the investigation of who the patient is and how they appear and everything that is necessary to land to a diagnosis. For example, is the history of presenting illness. This illness, when did it start? What has it caused? Something like that. So I'll be using some sample data we used with professionals as to how they would be writing these fields, and we will see how the system will predict. So for example, let's say we are dealing with a patient who is Am I audible, by the way? Hello?
Yes, we hear you.
Oh, thanks for the reassurance. So, for example, let's say you're dealing with a person who has emotional instability, history of cannabis use, something like that. He has been brought to the healthcare institution for help. So they will fill the history of the presenting illness, then they'll fill the past medical history of that particular individual, because it may have something to do with what they go through, or it may not have anything to do with what they're going through, but it is necessary. So for example, let's say this particular individual just had an appendectomy done, let's say an appendectomy done a month, or let's say 2 months prior. I'm editing some fields so that the model doesn't just use like the cache to fill or land to conclusions. So we'll fill other fields also, like family and social history. Let's say this particular individual has an unstable employment history and has some difficulty in family relationships. And let's say here there is nothing significant and general observation of that particular individual. Let's say the particular individual appears irritable and tense during interview, and also systemic observation. They can say if there is nothing abnormal detected, they will say so. Other reviews and clinical notes, the notes of the overall situation going on. They will say here, the patient presents with recurrent aggressive outbursts. They are aggressive and they have difficulty to manage their impulses, but the important part is the history of substance abuse or substance misuse, which was captured also here, which was cannabis. I think cannabis is marijuana, if I'm not mistaken. So after that, we'll send back to the model, and the model will check. Now, after checking, it's processing, so it's a bit slow depending on our infrastructure, but it will finish. So for this particular individual, we've been told that this particular has mental and behavioral disorder due to psychoactive substance use. Now, that may have seen that, may have been seen like through the not taking the model maybe got a clue because we kept insisting of history of substance use, but there are explanations that can be not so open as to what may be troubling the individual, and that's the point of the model, to help in identifying those kind of issues. So it will provide an analysis of the summary, also severity, but severity has to be defined or decided by the psychiatrist, because they're the ones seeing the patient. So there are things that cannot be expressed through natural language because it do not support vision for now. And also the follow-up and recommendation. After that, the doctor can save that particular diagnosis. Now, when this patient comes back again for follow-up, maybe during the start of the diagnosis, it will be specified that it is a follow-up, so that the model can also track the previous, can also use the previous diagnosis to help in case severity, to see how the patient has progressed. That's also done via natural language. So for example, when I go back here and I'm doing, let's say, same thing maybe for Ronaldo Juma, if I come here and specify that this is a follow-up visit and I go on,
this helps. We can show previous visit data, and the doctor can be using this to track or to see if there's any development in any of these, and they will say, so maybe if it's an unstable employment history, or maybe this time around they can say, okay, this particular individual in this follow-up visit, they've managed to secure a job, and they're in the job for maybe 6 months or a year maybe. And also for the other fields, they can also say something like that. And to the model, we'll send both these and the prior ones combined, so that we can help through tracking the previous and to capture the progress of this particular individual. So that's the tool that we have for professionals, be it psychiatrists or normal OPD doctors. But we also have a tool for the community, but it is I don't prefer saying limited, but it is different from this one, in a sense that for ethical reasons, it's closed-ended. So it just asks basic questions like, let's say, the particular individual's age and gender. Then after that, maybe Kulwa, you could mention that the AkiliCheck has 2 stages, where you have the quick check, and at the end you go for the full assessment. You have gone too fast, and maybe someone might have missed on that in the dashboard. Maybe you go back on the dashboard. Sure. So the community tool is done in 2 steps. First is identifying this particular individual mental unrest, because somebody may be feeling mental unrest and they don't understand, they can't pin it down. Maybe they don't want to land into conclusion. Maybe I'm anxious, or maybe I'm depressed, or maybe I have substance abuse disorder. So the first thing is to ask first basic questions as far as the emotion, how this particular individual is feeling emotionally, how their sleep pattern, any changes in their behaviors. Those kind of details can help in pinning down maybe this particular individual is going through, maybe it's depression. But saying just depression is not painting it as in bad light, because what matters is the amount, let's say, level of depression this particular individual is going through, because depression is basically stress or mawazo. Everybody has those, but the key question is here is how much is it? So for example, let's say an individual has 34 years of age, they're male, and emotionally, if they feel any of these symptoms, and by the way, this is all created using our own data set. We corrected that. We have almost 30,000 data right now, local data collected in our own hospitals. So if they feel any of these, they can say if it's none of the above, so that we don't guide them through having any of these. They can say none of the above. Let's say they're not anxious, but their sleep patterns, they wake up frequently and they have also difficulty falling asleep. And let's say any physical symptoms, let's say there is none of those. Their thinking and basically their cognition abilities at that particular time, not in the previous. Any symptoms that regarding cognition right now, let's say they're experiencing difficulty concentration, they can say so. And any behavioral changes that have been associated with this mental unrest they're going through, maybe let's say they've noticed they are socially withdrawing from people and having or experiencing self-harm thoughts, they can say so, and the model can say, okay, this seems maybe it is depression. But we also give a disclaimer that we're not replacing medical professionals, simply because the fields we are working with here are so limited for ethical reasons. We can't ask somebody about their family issues. They are not supposed to consent to those kind of details just to a system. If they can consent them to a professional, it's okay, but not to a system. So from there, they can go to a recommended assessment according to WHO standards for depression, which is PHQ-9. It asks 9 questions. Basically, the idea is asking from each question is to identify if any of these systems show up to that individual in that particular time they're experiencing the mental unrest. How frequent are they? how frequent is the symptom. So if you ask particularly video if they're experiencing having little interest, or even if they having little interest in doing things they enjoyed to do before, or even if they force themselves to do because they have little interest, they don't get the pleasure of doing them as before, be it going to work or being to study. They can say the amount. So let's say several days they experience it, which is normal. Everybody gets to feel that every once in a while. They get also asked if they feel down or depressed or hopeless, if they feel any of those symptoms, or both, or a combination of any, to how to what extent they feel it, they can say. So it goes all the way like that. Goes all the way like that for all the 9 questions. And the final question is about people who, anybody who has self-harm thoughts or thinking of committing suicide. So it's helped also to flag if a person is at that critical state. After that, we can combine those previous results and these ones and submit to get, although the final score is coming from only this PHQ-9, but to give a recommendation of maybe a lifestyle or recommendation of maybe coping strategies, we combine those previous symptoms to tell somebody maybe these are the coping strategy. At the meantime that you haven't gone to the hospital, you can do this just to put your mental state in a good form, then you can go on with your activity. Now, the aim of these coping strategies is to put the brain or to put the person in question in a good mental state. For example, let's say I go to Mirembe and I'm depressed because I have no job and I have no money. In reality, Mirembe can't solve my money issues or my job issues. They want me to be in a good mental state to go conquer those issues I have on my own. So the techniques they'll give me are the ones that will help me to calm my mind, which are ones we're very familiar with, but we just don't do them daily, or we don't practice them, which is the very first one is physical activity, like exercises. If you have a desk job, maybe you sit a lot on the computers, you don't interact much with people, it will be recommended that you get to interact with people. That's why there is a question in early symptom check. If you are socially withdrawing with people, it will be recommended that you go to interact with people, speak with them. If you don't have exercise, go exercise. If you don't have a good meal plan, have a good meal plan. So all of these can be captured from the previous questions that were asked, but they are trying to be as ethical as possible by limiting them to what they can answer, but rather than being expressive for somebody to just feel an open-ended field. So they won't reveal their private issues or private matters. That's it. Thank you. I'd like to welcome the questions or anything.
Maybe, Kuro, I see one question in the chat, just asking what problem are we trying to solve? Guys, I think from what Kuro has mentioned, the major issue that we wanted to address is the mental health issues. We know we have a limited number of psychiatrists, but also mental health hospitals. For example, maybe you could go to Mirembe National Mental Health Hospital or Muhimbili. We think because of the lack or limited number of experts, we are coming up with a tool that is AI-powered tool where a person can just take a self-assessment to better understand on the mental health well-being. So I think that's the reason behind, and you can just take a quick check and then you can just go on the full check where you interact with AI-powered WHO standard tools like PHQ-9 for depression or GAD-7 for anxiety and many other. So what we have done, we started with the data collection from 4 hospitals. We started with Mirembe National Mental Health Hospital. We went to Benjamin Mkapa, Amana Regional Referral Hospital, and Muhimbili. So what we have done after correcting the retrospective data set from the psychiatry clinical notes or maybe data set. What we have done, we did data cleaning and pre-processing, and at the end, Kuro and his colleague developed an AI model, which was trained by the local data sets that we collected out of these hospitals. And at the end, after the deployment, of course, after the training, we did a deployment within the, of course, the environment that we have at the University of Dodoma. And at the end now, end user can now take a self-assessment either using a mobile app or a web-based application. So our target is to make sure that this application is available to almost to our higher learning institution, but also in the community community areas. And in maybe for those who attended Sabasaba, we have managed to attend over 350 community members, and maybe we have also used some of these to publish some of the academic paper, and I hope once the paper are published, you will also be able to access some of these data. And if we are in Dodoma, we're also planning to be in Inane. So welcome to the University of Dodoma and the Nelson Mandela maybe tent, then where we will also interact with our experts. And within our booth, you will also find psychiatrists, counseling psychology, where after the self-assessment score, then the counseling psychology and psychiatrists will now give you the personalized therapy that fits your demand. Thank you so much. And thank you, Kura, for the wonderful presentation. And thank you for that.
Hello? How is my network?
Yes, Kura, we can hear you very well. Probably, yeah.
Yeah. I thought I thought I was experiencing network issues. I was just troubleshooting. So basically, how you've answered it is correct. First of all, it's solving the stigma issue around the topic of mental health in general. I don't know about you guys, but lately we've been encountering a lot of suicide issues in our country, especially for young individuals, youth, like most of us. So the idea is first to remove the stigma by bringing awareness tools closer to the people. If somebody is afraid to go to maybe hospitals, because we all know, if I tell you I'm going to Mirembe, there's some sort of mentality or stigma that a person can have. Okay. Dotongonde. The accuracy of the models.
Correct an individual. Yeah, someone was asking what about the privacy. So we don't capture any personalized information like names or any unique identifiers. So we, as you have seen, we just ask you the age, and we also ask you the gender. But we're also thinking of adding maybe location, because on a referral component, if we also capture your location, then it's quite easy to locate you to the nearby referral point. Thank you.
Regarding performance, the final model.
You can go ahead, Kuro. Thank you.
Yeah, regarding performance, the final models for the community tool was accuracy of 90% and F1 score of 97% for schizophrenia and 91 for bipolar. Those are the topmost ones. And for the professional ones, it's 96%, the beta classifier model. Regarding the fields used, I think this is basically the this is a very previous version of our model. We're still working on a new one because the previous version of the model was restricted to the data set we had collected. So there was a huge work done by Mr. Matogolo here, Dr. Matogolo, to collect a lot of data. So we got a lot of new data from Benjamin Mkapa and Muhimbili. So we are retraining to update the fields. But the one that was done before, I'm not sure if you're referring the professionals tool or you're referring to the community tool, but the community tool is to be retrained using the new data set we've just collected and still processing. But for the professional tool, one of the problems we encountered that we didn't foresee is the consolidation of how it's done. How it's done in, let's say, Amana, how it's done in Muhimbili, how it's done in Benjamin Mkapa is a little bit different during to the systems they have. So you can go to a hospital that is using a normal system for PD to capture mental health data. That means there are some fields that you will miss. So one of the tasks that we are doing or we're working on right now is to consolidate those fields to have a unison form that can be used, because other than that, we can't just pull it and push it to the model if the fields are not consolidated. Using Swahili language, yeah, it's possible to use Swahili language. For the community tool, is possible to use Swahili language, but for the professionals tool, it's not possible to use Swahili because the data set we had is purely in English. I think I've answered all the questions. If the moderator can go on, maybe.
Yeah, thank you, Dr. Kulwa. That was very important because we all know how important mental health is for everybody. Having a diagnostic tool like that will help a lot of people. Thank you again. And now I'd like to introduce Fredy Mgimba from Tanzania AI community to introduce Twiga, a tool for education. Karibu sana, Fredy.
Hello everyone, can you guys hear me?
Yep, go ahead.
All right, let me share my screen. Okay, can you guys see my screen?
Yes.
All right, so hello everyone, my name is Fredy Mgimba, and I am a software developer and tech lead on the Twiga project. And today I'm going to introduce you guys to the Twiga project. So we're going to see how it works, maybe like a quick demo, and also have a quick look on the code and how we work in this project. So first thing first, you can, Twiga is an open source project, so it's available on GitHub, and think for general overview, we can really use the README, the GitHub README to go through it. So I'll also keep the link in the chat later on. So first thing first, Twiga is an AI-powered chatbot to help educators. So it's a chatbot where teachers can use to do various things such as ask questions, get summaries on topic, generate exercises or exams, help in marking, and etc. So some of the key highlights, we do have some good sponsors such as Meta, through the Llama Grant Innovation Award, and also Neon is helping us on the database. So for a general structure of Twiga, we can see how general infrastructure is. So in short, user sends a message in WhatsApp to the Twiga chatbot. That message has been sent to Meta API. Meta API talks to our Twiga API, which is hosted in Render. And from that, the code logic goes on, and if there's anything to be saved in the database, we save it on our Postgres database, which is hosted on Neon. And if there's an LLM call to be used, we use Together AI to inference from the LLM model. Now, even for the vector embeddings, we're also using Postgres. So using PG Vector plugin, we'll be able to store the vector embeddings there. And also for the AI model, we use Llama models. So we're going to see it later on. Also, another key thing which we just added, I think which can be added in the infrastructure too, is we just integrated Langsmith, which is basically there to help us in monitoring. So here's just a quick example in like the dashboard. So you can easily monitor in terms of, you can basically monitor all the LLM requests which have been sent, and also add metadata such as the user IDs and etc., so that you can easily see your usage and then drill down to maybe user-based usage and etc. So today we're mostly going to have just general introduction, and think we're going to dig more deep, especially in the code later on when we're introducing the challenge and other things. But on top of everything, I'm going to share the link for the Twiga repository. And also, this is an open source project, as I said. We also do have some issues here. So if you know a little bit of Python, or you just want to find a way to contribute in an open source project, you can go ahead and check the issues. And we welcome anyone. You can create a new issue, you can just comment, and then you can get yourself to be one of the contributors in this wonderful project. So are there any questions up to the moment before I go to a quick demo?
Maybe I do ask one question. How many teachers have you registered so far? I know some of the local teachers have been using the Twiga AI, and we've seen some wonderful feedback. So in your tracking features, how many local teachers are using the Twiga app? Thank you.
Okay. So right now, we're going to see Twiga live on WhatsApp, but the project is still in kind of like alpha testing. So we haven't given it out to all the teachers to use it all the time. We have very few whitelisted numbers. We're just testing on time to time when we need to do some research. But pretty soon, we're going to actually scale up and have it public to more user base. So in terms of how many are using right now, we can't really have a proper number for that. But we have tested, I think, in various schools, I think about 3 schools, about 20 teachers, and we got some good feedback from them. And through that, we're using it in terms of improvement. But generally, our roadmap is by end of August or early September, we're going to have a more public launch. And through that, we can get to have more feedback from teachers. Thank you. Is there any other question? Right, so let's just go and ask a few questions. Yeah, I hope you can see my screen. Yes, so this is Twiga. So this is the live version on WhatsApp. So for example, here I can just say hi.
Hi, Fredy.
Yes.
Sorry, hey, Lonnie here. Sorry to cut you off. We have another presenter who needs to leave the chat soon. So do you mind if she kind of goes on for 5-10 minutes, and then you can continue maybe tomorrow during your session? Because you'll also be demoing the tool, tutoring the tool, right?
Oh, okay. So no worries. I'm basically done. I just kept the demo as the last thing. But again, we can dig more deep later on. Today we're just having a general introduction. And so that's everything on Twiga. And I'm going to share a few resources on the chat for anyone who wants to learn a bit more. But that's it from Twiga. Thank you, guys.
Yeah, awesome. Thanks, Fredy. There might be some questions in the chat that you could answer if you could too. I think, I'm not sure.
Okay, let me check.
Got a few. Great, thank you. And we'll hear more from Fredy and Twiga in the coming days because they also have a challenge ready for us, right? Okay, so next presenter is Dr. Theofrida Maginga, and she has her tool MkulimaGPT. Dr. Theofrida, are you online? Yes, you're sharing. Okay.
Yes.
Karibu sana.
Sante. So basically, I have only like 5 minutes or so, and okay. So the idea is to share the work that we are doing, and it's called MkulimaGPT, and MkulimaGPT is part of the research work to assist farmers and to help farmers to be able to detect diseases. As you can see on the background, we have a picture of a farmer. So this one is from Gairo, and we're about to harvest, and they're facing so many issues in the farm. But you know, there is an advantage of using technology. And for anyone who is an AI or you want to use technology in different aspects, I know we have talked much about the chatbots, but my interest here is to show you that you can as well use IoT sensors. You can collect data from the local areas, from the farm fields. So in this case, we used sensors to collect some of the emission from the plants, and also you can collect data and like climate related data. And we took those data, cleaned those data, and apply some deep learning models to detect for any anomaly that comes from the plant field. And then the chatbot came at a later stage. So if you're interested to utilize artificial intelligence, not only in the chatbot or in the other aspects, you can as well use some climate data, and you can be able to predict some of the situations that are going on in the field, especially in the farming aspect or in the agriculture aspect. And just to give you a context of how we implemented our solution, we used one model specifically that we trained on our data, which is an LSTM model. This is good for temporal data or time series data. So in this case, our architecture works in this context where a farmer can either input their sensor ID. So if you have an IoT device placed in the field, you can put a specific sensor ID, and then that sensor ID will go and retrieve all the data from the database. So on the local host, we use the SQLite database where we have a data, and then does the data pre-processing and then do the prediction. And then the prediction results are being sent to the OpenAI API. But also a farmer can ask general questions about farming activities. And you can use some of these tools that I've shared here in the architecture, and then you can try it on your own in different contexts, not only in maize, because we're only working in maize right now, because it requires a number of experiments, and also it requires going to the field to work with farmers directly. And then if you want to host it locally, you can use the Flash server. You can do it via Twilio API. So Twilio API can help you to navigate around WhatsApp chatbot for the local testing. And also Twilio is, you pay a little small amount of money, and then maybe well, 10K will be enough to start testing your application. So this is the architecture that we're using. So you have the IoT data, and then your own model can do the prediction, and the OpenAI can give context of information. So more of the context of information that we got to give to the farmers. We collected a lot of data from the farm field with farmers as well to give us information about how do they cultivate maize crops and what would they like to see from the chatbot side. Because as we started, because the general OpenAI API was just on the starting base, so the language is not really quite what was expected. And this screenshot, it has two parts. So if you can look closely to the screenshot, you can see if you're using IoT sensor, you can simply, a user can simply put that IoT sensor ID in the chatbot using a WhatsApp, and then it will go and query the data on our database. It will detect if there is any anomaly, but the message that you're seeing here is simply a message that was generated by the OpenAI API or the large language model chatbot based on the results that we give. So our tools, they're giving the results to the API, and the OpenAI API can dissect that information into a context that a farmer can understand. So this was just for testing. That's why it's in English. But also we're able to test if you input your location. So you can as well utilize some of these tools. You can put your location in front. Based on your location, it can give you information what to do based on that location and the weather, because of the change of climate conditions nowadays. You can utilize that aspect. So what do we have that is live that you can test or you can use? It's a general chatbot which is called MkulimaGPT, and the chatbot has this number shared on the left side. You can see here. So this one is live. You can test it. You can ask general questions, but the IoT aspect is the one that we are researching much more on, because we need a lot of local data and a lot of experiments and field visits. And there's also another side of the AI that you can utilize. We don't only build chatbots, but we also analyze some of those results that are coming, the conversation that the user is having with the chatbot in an anonymized format, where we don't keep users' information, but would like to validate some of this information and see whether the chatbot is giving the farmer, is it the right information or not? And we're using experts in agriculture to do so. So we have been able to test with about 123 users, and we have collected number of messages, you can see, but we're doing validation of this information so that we can correct the bot if language needs information, needs improvement, if the information is correct, and if it's very specific or not. And feel free to look at go to MkulimaGPT on Google on the website, and then you can test the tool, the general chatbot. But also feel free to reach out to me on LinkedIn. I'll be happy to share some of the versions of this work and how we have explored different tools of AI and how best you can as well utilize these tools into your own solutions. So that's it, and thank you. If there is any question, I'll be happy to answer, maybe like one or two. Yeah. So silence means I was understood, or I confused all of you, and kama mmekuwa confused, poleni sana. But if you understood me, thank you. And if you have any questions. Oh, okay. So is it a large language model? I mean, can we use Swahili? Please, okay. So the large language model just comes at the very, very last part of our application, because the idea is to utilize IoT devices so that they can be able to detect or inform a farmer on what is going on in the field. But because you not only just end up into identifying what is going on in the field, you want to give an information to a farmer that the farmer can understand, not in a technical way. So that's where the large language model comes in. And this work is just a part of what we can work with people like, you heard the PAWA AI, that was like a base model. So you can use some of those models to just inform the farmer on if there is an anomaly, what should you do, what should you do not. So that's where the large language model comes in. But basically our work, we collect our own data via IoT sensors, and we do the prediction by using LSTM models. So this one is not entirely based on large language model. Okay. So where does the data set originate? Yeah, we set the tools in the field. So in the maize fields, we collect data by using IoT sensors. And if you're more interested into IoT, please reach out to me. I would love to guide you around the use of embedded devices to collect data, because we can collect, I know, text and sound, but we also need to collect environmental data so that we can be able to predict what is going on in the environment. So that is also another part of the work that someone might need to explore. Not only images, you can collect data by using sensor temperature, by using gas sensors. So these sensors are also, you can buy them via Amazon, and then you link them to your embedded devices. And then when you collect those data, you can use those data to train the model to do prediction, to tell you if there is something going on or not. If you want to check air pollution for people who are living in Dar es Salaam, you might want to work around the air quality sensors so that you can be able to predict if the air quality is going to be terrible, it's going to be good, and things like that. So yeah, I have limited time. And last question for Sir, can we see live demonstration? If you want to see live demonstration, please reach out to MkulimaGPT website. And what about farmers or people who lack skills to use tech devices? And I think this should not be an excuse not to develop tech stuff, because people need to be taught how to use tech devices and tech solutions. So we have to be the champions of developing these tools and teach people how to use these tools. And I've been working closely with the farmers. They're more curious. They want to know how to use these tools. So as long as we can develop them and we bring the tools, they will learn how to use them. So that should not be an excuse for people to not develop technological tools. So thank you so much. I will have to rush to another meeting. I'm so sorry.
Thank you so much. Hello. Thank you so much, Dr. Theofrida Maginga, for a nice and interactive presentation. I now welcome Alex Mkwizu, presenting on Tausi, Unlocking Access to Finance for the African Informal Economy, FinTech. Welcome, Alex.
Hi everyone, hope you're doing good. Give me a couple minutes pulling up my slides.
Hello?
I'm
Alex,
pulling up
you
slides
can't hear.
and hello, can you hear me?
Yeah, I can hear you now.
Okay, awesome. I'm pulling slides in 1 minute and then we can start.
Are you speaking? You are muted.
Hi everyone. Can you guys hear me?
Yes, Alex, go ahead. We can.
Awesome. Cool. Hi everyone. My name is Alex Mkwizu. My background is in computer science and decided to focus more on data science, strategy, business development, but also I do creative arts in technology. But for this case, I'll be focusing on our work at Black Swan in using artificial intelligence in building credit scoring models and algorithms that they help a lot of millions in Africa who do not have collaterals that can enable them to lend. So the situation mostly in Africa is we have adopted the European or the Western systems, whereby to get credit you have to have a collateral, or there is a program in the government or a non-profit or a development partner whereby they are guaranteeing those loans, maybe 80% or 75%, right? But with this situation, there's a huge gap left whereby most people can't access loans, and through loans, you can be able to elevate yourself from one economic level to the other. And that's what Black Swan is actually solving. And the reality is we have this financial data, but people aren't looking at that data. So most of us, we usually revolve or move a lot of money through mobile money and bank accounts, right? But when you go to a credit scoring institution, whereby they want to give you some money, they will ask if you have a collateral, right? Why not just look at how you move your money, how you pay your bills, or any other loans that you get, so as they can provide you with a proper credit within the amount that you can pay, right? So most financial institutions, they really don't see the financial story of everyday Tanzanians, and in Africa too. And as I said earlier, most of the traditional systems, they rely on pay slips so as they can be comfortable that you will definitely pay their loan if you are employed. But most of the Tanzanian people / African people are unemployed in terms of like the formal employment. But they might be moving a lot of money. Either you are a machinga or you're just doing a digital business. You're moving your money, you survive, and you need loan maybe to get another package of goods. You can't, right? Because we have relied on pay slips and collateral. So what happens is that lending remains slow, costly, and biased towards the urban salaried few who are also privileged to have like properties that they can use as collaterals, or they have access to guarantee schemes, either from the government, development partners, or any other program.
Making crud time from bank statements optimizes over 1,000 data field decisions, all in under 3 minutes. No need to comb through 300 pages. Banca pulls what matters fast and gives you a clear affordability benchmark showing exactly how much a borrower can repay. And yes, it checks if a document is authentic. Fake or edited, flagged instantly. Got questions? You can always ask Banca. What's their 3-month cash flow? Have they taken mobile loans before? Just ask, get the insight, make the right call. 50+ institutions already use Banca. Are you ready to join them? Banca helps you make the right lending decision with confidence, not guesswork.
Cool. So that is a very brief marketing intro on what exactly we do. So ideally, the process flow is that one would come, they need a loan, they would ask the person who needs the loan, the borrower, right, to provide their mobile money, merchant till, or bank statement, and then we analyze that, and then we provide a credit score and an affordability to say that this person can afford to pay this amount of money and during this time period, right? And our solution basically focuses on 3 areas whereby we help these people, either you're a bank or an MFI, to acquire customers, and then we can tailor those financial experiences with respect to your customer, because every person has a different financial footprint. So how can you tailor the loans and the marketing messages to with respect to that person's cash flow, right? But the third part is basically how do you streamline credit decisioning to the MFIs and banks. When I say MFIs, I mean microfinance institutions. And this is simply a demo on how it works. Either you go to your M-Pesa statement and you choose maybe a 6-month statement. And then we had already created an email, absalife@manka.tz. So when you just send the email, yep, you're done. But also it can be done through USSD. So we are looking at the last mile population whereby they can't access or the internet is very slow. So banks, you can request your statement through USSD and send it to a particular email. So on the other hand, that is sending an email statement through RDB, which is quite simple. In less than a minute, you've already sent, and when you look at the dashboard, you definitely see, you can check if the document is verified by looking at the PDF data, and then you see these holistic data points, whereby you can use them to customize your own affordability or credit score with respect to your, what would I put, like your appetite, that's the right word. But also you have visualization graphs as a credit analyst to see how that person moves money, because sometimes you might see there's a huge cash flow. However, maybe that person just actually moved money to show that they have a constant cash flow, but when you look at the average movement of money, it's below the bumps that have been provided. We also we have an LLM for querying this particular data to customize, to look for either gaps or to help you to summarize all the data points that you're specifically looking at. Awesome. So yeah, the key thing about lending is you can lend manually, right? But as a microfinance institution or a person who's looking at to do a microfinance business or launching a digital bank or just a normal bank, you can easily lend, but can you scale? Because the business of lending is all about scaling fast and efficient and ensuring that there are few non-performing loans, or in simple words is that very few loans that people don't pay, right? And we've been able to work with around 50 plus financial institutions and a 4% less NPL, which roughly is around 2%, but ideally we usually have a stricter way of measuring NPLs. So that is why our current testing phase is around 4%, but the actual NPL is around 2%. And yeah, so basically we are looking forward to scale into having more for like a marketplace between two parties. Ideally, you have people who are looking for loans, and then there are people who are providing ideally device or asset financing. So either you're looking for a car, you're looking for a phone. So there are microfinance institutions that provide financing for those particular assets, and you just put your mobile money, merchant till or bank statement, and then we pre-approve you and send that lead to that microfinance or bank, and then they will look on how they can give you that financing with respect to the extra due diligence that they will do to ensure that you're the right customer and you have the right history. And yeah, so far we are working with Credit Info on open banking and instant credit insights. We are working with Celcom, powering the Gisoti loan. Hopefully most of you are using Celcom. It's the best app that you can have to do your transactions. It's cheaper. It has best customized services. You can save through Celcom, and it's easier to send money even if you have someone around East Africa, around Uganda or Kenya. That is also possible. And we are also providing custom credit scoring with Mkononi in the pharmaceutical supply chain. Yep. And that is our management team, who they drive the vision, the technical capabilities and all that. So I will stop here and I would allow a room for questions.
Yeah, thank you. Alex Mkwizu for the nice presentation. Any question?
Thank you.
Please, Kalebu. Or you can keep it on the chat box. Okay, now I'd like to welcome our last presenter from SOSA, presenting on Bahari. Can they hear me? Presenting on Bahari, a user-friendly approach for testing machine learning algorithms across multiple case studies. I'm not muted. Yeah, karibuni. Hello. Unmute. Hello. Hello. Presenter from SOSA.
Hello, the presenter from SOSA is not available, but however, he recorded the video. So let me share my screen so that you can see the video of the presenter. Yeah. This one. Do you see my screen?
Yes, Akram, we do.
Okay. So let me play somehow long, but we'll see how we can make it short.
So without further ado, I would like to tell you what is it and why we need Bahari for. When you want to develop any machine learning algorithm, for instance, you have a data set, what is the typical procedure that you follow? First, you will start with data pre-processing. And when you do the data pre-processing as a machine learning engineer, there are a couple of things that you need to consider to prepare the data for the modeling part.
Hello. Oh, can you turn on the mic? We cannot hear the presentation.
Imbalances between the classes or categories, you need to handle that because you know it is going to affect you when you develop your machine learning algorithm. So this is the second part. The first part also you need to consider when you're doing the pre-processing is how you're going to split the data set between training data set and testing data set if needed. It is mostly needed for the evaluation part later on. Another thing that you can also consider is if you want to do stratified sampling or not. And there are other aspects that you also need to consider when you're doing data pre-processing. My message to you here that when you're doing pre-processing, there are a couple of things that you need to consider, and there are several options to select from. Which one is going to give you the best performance? You don't know yet. You're trying to choose the best based on the context data. But again, our mission here is to make sure that you're developing the highest performance algorithm in the next phase. So this is it, the pre-processing. Once you're done with the pre-processing part and the data is ready for training part, you move on to the second part, which is selecting the right algorithm. And as we know that if it is a classification, for instance, kind of problem, there are already a number of existing classification algorithms to select from. You don't know which one is going to be the highest performance based on the data set. If it is a regression problem, again, there are a couple of algorithms that are already there, you need to select from. But all in all, we all understand that there is no universal best algorithm that performs the best in all the ways. No. As machine learning engineers, we understand the performance of the algorithm depends on the data set. So we're not really sure yet which one is going to give you the best performance. And that's the reason why we have these benchmarking tools so that we select the highest performance algorithm. But how do we know if we don't test a couple of options to select from? So this is the second part. We did the pre-processing part, which is a couple of options and scenarios to select from. We go to the selection of the model, which already has a lot of options to select from. So, for instance, we are selecting a particular method. Now we go to the training part. And even the training part, there are a number of options that we need to consider. Are you going to train using default hyperparameters? Are you going to train using a customized hyperparameters? Or are you going to tune hyperparameters? And if you decide to tune, there are a couple of methods that you could use to tune your algorithm. You could use grid search, you could use random search, you could use Bayesian optimization, you could use genetic algorithm, any group of optimization techniques that you could use. So you can see here, from the processing, there are a number of scenarios to be derived from, and then going to the selection of the algorithm itself, going to the training part, and even the evaluation part. There are a couple of combinations that could be built at home to make sure that we are going to have a high performance algorithm at the end of the day. So myself, when I was doing this model development, it was taking me a lot of time to test a couple of these things. So I thought of why don't we have a tool that could help us to help the researcher or the machine learning engineer to set all these configuration, possible combinations of configuration in one place, then just feed into the tool, and the tool will develop each of those combinations or configurations and provide the results at the end of the day. So this is the whole idea here, that we provide a tool that is able to give consistent and replicable approach to testing machine learning algorithms in several categories. And interestingly, we also want to see the performance compared to traditional statistical methods. So we know that linear regression is the father of all regression techniques. And we know that reducible regression is also the father of classification techniques. But in terms of complexity, these statistical methods, they are way less computational expensive compared to high computational demanding machine learning algorithms. But even though machine learning algorithms are complex, it is not guaranteed that they always give you the best performance. Sometimes a simple linear regression is able to perform better than a very complex artificial neural network, and we have seen this in the research. It's quite possible. So you also need to see how these complex machine learning algorithms are performing compared to the traditional statistical method. The tool itself is able to give the flexibility. You can be able to apply this in different case studies. So far, this tool has been successfully applied in building science, with image studies in buildings. Also, we have also applied this tool in education. We have applied this tool in predicting fake orders, in supply chain. Yeah, so it is showing that it is flexible in a couple of those case studies, and the application interest is there for you to apply to different domains and see how it performs. Also, we thought of having a tool that is going to have a user friendliness and time efficiency for all those tools of use. So for this case here, you're talking about researchers, and you can see that we sometimes spend a lot of time developing machine learning algorithms. And now we want to see how we can replace that time that the researcher is working on developing algorithm to focus on an analysis part and the fabrication part. The possible combinations of scenarios when developing the machine learning algorithm will be handled by the tool. And this saves a lot of time of researchers and machine learning engineers. Also, there's a picture here of Haroun Gwalugano. It is also providing us an option to either run this tool in a local machine or an HPC. So when I'm talking about HPC, I'm talking about high performance computers. So this HPCs, they are giving us a functionality of being able to run those algorithms parallelly, which is actually cuts a lot of model development time, because when you develop one machine learning algorithm, and if you're tuning the parameters, it will take you 8 hours, for instance. Now, if you have 100 scenarios that you want to test on, it's multiplied by 8 hours by 100 scenarios, that's a lot of time. If you're going to execute them sequentially, which is the case if you're running the tool in a local machine, I will explain about this later on. But if you run this tool in an HPC cluster, then those 100 scenarios will be run parallelly and be able to have all those results in probably one day or less than 20 hours, which is a huge bonus for the service that we get the results earlier for them to focus on analysis and writing part. It also has the opportunity of allowing you to test completely new data sets. So you can use one data set to train the algorithm, and once the algorithm is trained, you can use a completely new data set to see on how we can perform on that training the algorithm. And it is highly scalable and customizable. Right now, it has a couple of methods that are being pre-coded into the engine, which I will explain later on. But you, as a user, if you wish to have any new algorithm, any new sampling technique, any new imputation method that you want to include in the tool, you can do so, and you can easily cope with your demand and your needs. So it's highly scalable and customizable. So this is how it looks like. It's a very simple tool. It is composed of 4 main segments. Configuration module. This is the very important part that I was explaining to you. But now you don't have to worry about a couple of combinations that you need to go through again and again and again. All you need to do is set up everything. I will explain this in detail later on how it works in your configuration module. So this is the part that you decide what you want before running any machine learning algorithm. So once you are done with the configuration part and your configuration module is ready, then this is going to be feeding the ML engine, and this is where we have pre-coded several techniques and algorithms, and there's still a room for you to include any methodology you wish to have in this ML engine. So it will receive this configuration module and execute those algorithms one by one if it is running in a local machine, or if it is running in an HPC cluster, then it can run parallel. Once it is done, all the results are being put in a CSV file and they are being pushed to the results module. So for you as a researcher now, you don't have to worry about the coding part. This part is been handled. So we consider this tool as a no code or very low code platform whereby any researcher from any discipline who wish to apply machine learning into their studies, they can do so using such a user-friendly tool that we're talking about here. So that's it. It's 4 components: configuration module, the ML engine, a results module, and down here we have the execution module where you can choose whether you want to run this in local machine or HPC cluster. I hope that is very clear. So now I will dive in each of these modules so you can understand what do they present. Let's start with the ML engine. So a typical workflow of the machine learning development process consists of 4 phases, as I was explaining before. So you can see the phase 1 is the data pre-processing part, whereby you can select a couple of options. If you want to impute your data, yes or no question, of course. And if you want to impute it, it is yes, it will ask you which kind of imputation techniques that you wish to impute your missing values. Data splitting, you will also have the option to select the splitting of the data set between the training part and the testing part. For instance, if it is 80-20, then you just say 0.8 or 0.2, which is the testing part. And then you wish to have, okay, let me see how 70-30 looks like. So you can have a separate, everything looks the same, but a separate configuration where you only change the data splitting part. This is the power of this tool. So you only change that the data splitting value. So now you have 2 results. You have same, you have a result for the 80-20 split, and you also have a result of 70-30 split. It is helping us as a machine learning engineer to see which split is actually giving us better performance. And also, if you are looking for a feature scaling techniques, you can also try that with the different configurations. Each of configurations don't have a dedicated feature scaling technique, so you understand which feature technique, scaling technique is giving you better results. It's a very powerful feature for researchers and machine learning engineers who wish to optimize their model performance. So in phase 2, the model selection part, this is where you're going to select in phase 2, you're going to select which algorithms that you wish to train your data set on. As of now, there are 7 classification algorithms and 5 regression algorithms. It is Kalebu, more algorithms can be as you wish. And this is an example of the code that we have used. Also, third phase is a model training part, and whereby you can choose if you want to train a model with default parameters or customized parameters or tuned parameters. Whereby you can also have an option to choose which tuning algorithm you wish to tune the parameters. Grid size, random sampling, and optimization. And finally, it's a model evaluation part where now we have a total of 8 metrics, 4 for classification and 4 for regression. We have also included additional metrics that focus on the tuning time and the model testing time, because you need to understand sometimes there might be a model that is able to perform better, but actually it is consuming more time. And there's a model that is performing comparably lower compared to the other one, but in a significantly short time. So there are trade-offs here of model performance and complexity issues that you also have to consider. Yeah, so this is the end part, and this is how it looks like. I hope that is very clear. Again, if you wish to include any technique or method into the engine, it is very possible to do that. And as you can see, later on I will share the GitHub link. This tool is publicly available to anyone. And if you go to the GitHub link, you will see these components or parts of the ML engine distributed into different files, where you'll be able to open a particular file and link to the main file. So in terms of configuration model, we thought about it, and we thought of it in a way that we need to have a feature or a tool or a platform that people are quite familiar with, because we've been looking for a way of how we can bridge the gap between machine learning or computer science or data science domain with other domains that are making these computations or coding skills. So we thought of having a spreadsheet would be easier because it's familiar for most of us. So we start with an Excel sheet, and we have pre-formatted an Excel file, which calls it an input form, whereby each row in that Excel form is representing a single configuration or a single setting, and each column refers to configuration parameter. So let's have a look at it. This is how it looks like. This is an Excel sheet most of us are familiar with, and it came out with any spreadsheet. So for now, you can see this file in 4 parts, whereby the first part is the configuration, setting configuration part, and there is a data pre-processing part, which is what I was talking about. All these columns here in the middle, between this red dotted line and this red line, everything inside here is about the data set. So there are a couple of options that you can choose from for your data pre-processing part. And then the third part is the ML model setup, whereby you choose which algorithm that you wish to train your model, and if you want to choose hard parameters, which one are you going to use for model training, default one, or tuned one, or customized one. And if you choose that you want to use a customized or you want to tune, then there are a couple of other parameter set up columns where you specify a grid, a range of values for particular hyperparameters that you need to optimize on. Those of you who are machine learning engineers, they know exactly what I'm talking about. So yeah, so let's start to look into each of these 4 components. The first one is the setting number, and there's a column called selected here. To make a long story short here, imagine yourself that you have 200 configurations. And in those 200 configurations, now when you fit them here, it means you have 200 rows. As we have said, each row is a one configuration, is a one model, one possible scenario of the model. So if you have 200 scenarios, and then after having your results, you want to know exactly which results refers to which scenario. This number is going to be very important, because now you know if you are going to have a result for setting number 56, you just come back here and look what was setting number 56, that will be a column, a particular column down there. So you just go through it, and there are a couple of features that they also do the results to make things easier for you to understand which use case that particular result refers to. But this is the whole point of having a setting number here. And then it is selected if it is yes or no. This is like a switch now. For researchers or machine learning engineers, even if you have the results for 200 configurations or scenarios, sometimes you notice one of those scenarios, there's a room for better improvement. So you don't want to go back to your configuration mode and run all 200 again. No. What you need to do, you go to your input form, you switch off all those remaining 199, and you just keep the one that you want the model to the engine to run as yes. So the engine looks into this column. If you say yes here, this particular column here, if it is yes, then it will run that model. It will retrain that model. Otherwise, it will skip it. It's a very powerful tool for researchers. It is saving a lot of time. So that is the setting configuration. And the data pre-processing, we specify the data file name, your input values, which we call it as exit, your target value, which is P1. To do, just select from here. There are a couple of options you can go down. One feature scaling, if you say yes here, then you choose this technique you are going to use. This is not the next column. If you want to split the data set, if you say yes, if you look into this column, it's a failure, it is split here. And if you wish to have a, you want to fix the random. The solution is something that is used. So you can see here, looking into all these 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 10 columns, you can see there could be a number of scenarios. They're giving the same data set. You can try different input values. So if you look at 20 inputs, independent values, you can try combination of all those 20, or we select only 10, or we select only 5, or we select highly ranked values or variables that impact the body very much. So you can have a number of scenarios where we select different subsets of the input to see which inputs are going to give you better performance. And also sometimes you notice the data set where you think that input is not one subset. You want one different variable. There is a couple of different variables you want to do there. So you have different scenarios for the wires. And again, different combinations to the main first. And again, if you go to the political and you say the classification probably the which method and if you wish to tune the parameters, you also want to customize the and also there's a different validation. So there are some of the people so sometimes you see in literature, sometimes you see The most common one is 10 goals. It's very common. I've seen a couple of papers and reviewed a couple of papers, but they use 8, they use sometimes 5, sometimes 8, 7 goals. So we don't really know which goal is going to impact positively to your model performance. So we need to see how this approach is affecting your model performance. So this is another thing that we can have a number of scenarios as well. Yeah. And these are not running of approaches. So this is a typical configuration model how it looks like. So you can see here the first row, the first setting, which is the number of inputs, and if I run it, then I'm going to run model using default value. And notice between the first and the second row, everything is the same, but now the fact parameter here, I said I want to use default value, I want to use the second one to tune that. So I will see the performance there with the default value. So I need a different yeah. Now I want to set the random set. I want to use the blue size. I want to use the same, but now I want to see it also in the different. Because these one is a random set. With a specified number of iterations. So if you say 50 iterations, you will do the combination 50 times. So if you do the best out of this, and if you set you do 4 combinations. So sometimes it might convince, might use the best combination. So yeah, a typical study, at least from my experience when I was doing my research, studying my research, it's very typical to get models, and even more, depending on how so if you see how far comes the taking to the dog each line manually into the code there, you can see failed and it is time consuming, confused with first time. But now it's well organized, well structured, it's a semantic approach where now I'm doing the benchmarking of my algorithms in a very simple, user-friendly approach. And based on my experience developing this configuration model, for my studies, it could take me only half an hour then to see the combination that I want. Then I put this file into it, into the ML feature. And the ML will execute each of those lines and give me the results model. And this, me as a researcher, I'm interested in looking for which of those combinations will give me the best result. So the results have been compiled in output file, which is the CSV file, and named it results summary. There are a couple of rows, and this is how it looks like below. And there are a couple of columns that I included for you to see, to refer to which kind of setting these results they refer to. For instance, if you look into the setting number, remember we focus on the setting number in the configuration file. So this is telling me the results for the setting number 50. And also the file that we use, whatever input value, whatever public value that we use. And a couple of basic information to just give me information of even the method that we use, which kind of setting that we use. But then follow training results and also testing results. And for over TPDs, it's very important that also training and testing where we compare how the models perform and generalize it with an answer data set. And also there are a couple of parameters and feature importance column that I've also included into the results. And this is how it looks like. So imagine that the first 100 configurations we have the engine and the energy is given to the compact to the experiment, and you see to how it goes to the results. It is amazing for researchers to see something like this instead of taking time to record each of these individually and record them separately. Having such a functionality is really nice feature. I'm emphasizing research to the researcher. But again, this tool could be used by anyone interested to use it because even machine learning they go through the same process. They need to enter the research, but even the test model, so we get the same idea. And as you can see here, that it is quite user friendly, and it is allowing you to focus on the knowledge part and focus on the coding part. And so now we have covered the configuration model, the MMA, and the task model. The resolution model is simple to understand because the only options whether you want the local machine, whether you want the local machine, those 400. If you have 300, if you have 400 configurations, it is sequential. Setting number 2 will not be executed until setting number 1 has been deadlocked and the results are considered in the reverse file. It will make part of the project. It is user-friendly, it's nice, but if you run it in a local machine, sometimes it is taking more time for you to do it. Of course, you don't have to wait to come with this is the into the first model. But which I recommend, another option is to have an access to an HPC cluster, or even if you do 100, you run them into the HPC cluster, then you run them in parallel. So typical experience will take 2 or 3 months to look for the stuff. Run the same experiment in the HPC cluster, so it's taking me only 1 or 2 days. So it's quite powerful, to have shortening the data, putting the machine learning algorithm in the document part, which is almost 5 times consuming and very expensive, particularly if you're dealing with hard parameter. So yeah, in summary, this is it. This is the Bahari framework. It takes 4 main parts: integration model, and the model. I officially published this framework in my paper, published in 2024 last year. It is available through my Google process part. You will see it, but you can search it. If you wish to use this tool, you are very welcome. I will insist, please, if you will use this tool, please don't forget to cite this paper. Get to track how the model is performing in other studies as well, to see how we can improve it. That's all from my side. Thank you very much. If you have any questions, comments, or suggestions, please feel free to email me. I will put my email in the first slide. Thank you very much. Look forward to seeing your questions and comments.
Okay, that's the presentation from Dr. Abdulrahim, and this is the email. Anyone who want to reach him, he can check this email. So thank you.
Yeah, thank you very much for the presentation. Now we are winding up, and for closing, I would thank everyone for participating, the one who are physically at Susa, and the ones on the hub, and the one joining visually. Thank you all for being here for this. And I would like to also thank all the speakers of today's for their nice presentation. Yeah, thank you. And I would like also to remind everyone that this is just our day one. We'll be having 4 days. So please keep on participating. We are wishing to see everyone who is here tomorrow, Pia. Yeah. So that's it. Thank you. See you tomorrow.
Have a nice evening. Same link tomorrow.
Thank you. See you.
Bye.
Thank you. Thank you. See you.
Joni and Gemma. And Chana. Okay. Seems like Joni.
Mchana mwema.